For decades, the Perl programming language has remained important in the realms of text processing, system administration, and even web development. Learn how to use Perl in this complete course for beginners. This course covers topics ranging from basic syntax to advanced topics like object-oriented programming, regular expressions, and web development. Valters has been using Perl for years, and he will teach you how to use the language in your own projects.
Hi there, and welcome to this lecture. In this course section, we will be mostly working with Perl script files. However, before we proceed with looking at Perl file structure, I just wanted to quickly show you how you can run Perl through a command line interface. Now, in order to run Perl through a command line interface, you can type Perl space -e for execute, then single quotes or double quotes. I usually tend to use single quotes because with double quotes you can interpolate variables, and let's use single quotes for this example. And let's do something like print, which is going to print something to a terminal, double quotes, so they don't interfere with our wrapping, single quotes of our Perl code, and say hello. And let's also add a \n, and the \n is simply a new line. So if we run this by hitting return, we're going to see hello printed to our terminal. Now, the alternative how you can run this is with capital E. And what capital E does is simply enables some of the Perl core features. We're going to look at some of these features in next lectures, but for now, let's explore a very simple and handy one, which is called say. And this say feature is simply adding a new line at the end of whatever we're printing. So if we run this code again, we're going to see hello, new line followed by another new line. So it's automatically adding a new line at the end of whatever we're printing. Now if we remove this new line, which we added in the string, we're just going to see a single new line, which is printed after our hello. If I would try to run this with lowercase e, I'm going to see an error, and that's going to say that there is something wrong at line 1, and if we forgot to declare say, well, technically, yes, we didn't declare say, and the say command wasn't recognized because we didn't enable features. So Perl didn't know what say means and what it is supposed to do. You might be wondering, why would this be useful in general? Why would I be running these one-liners? Well, sometimes writing full script file might be an overkill. Maybe you just want to quickly parse some input via Perl. In this case, writing a script file is probably not the best solution. Just to give more elaborate example, and don't worry about the syntax, we will look at it in the future lectures, but let's do something like Perl -e, let's do capital E, then single quotes, where we can add our Perl code, let's say while, which is a loop, and then opening and closing parentheses. Let's add this diamond operator, which is taking an input, then opening and curly braces for executing our while block logic. And let's add something like say, UC for uppercase, and let's use this $_ And this $_ is simply the current context the while loop is receiving and what we are working on. So, but to put it simple, it's a while loop which takes an input from our terminal, it runs indefinitely, and is going to print whatever we're giving or script and uppercasing it. Well, it's uppercasing it and then printing it out. So if we run this, we're going to see that nothing happens. And this is because our program now is waiting for an input. But if I do something like hello, lowercase, hit return, I'm going to see uppercase hello printed out. And that's what I talked about. Basically, our program runs, takes an input, it uppercases the input and prints it out. Now, of course, there can be hundreds of other more useful scenarios, such as listing files, parsing file names, replacing file extensions, so on and so on. The scenarios really depend on the use case. But now you know how you can run Perl through a command line interface if ever you need to. I hope you found this lecture useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video, we will explore a basic Perl script file structure. Let's begin. Here I am currently in my Visual Studio Code editor, and I have opened up an empty folder. If you are using Visual Studio Code as well, you can open up a folder by going to File and choosing Open Folder. From there, you will get a File Explorer pop-up and you can navigate to the directory in which you want to work in. Let's create a new Perl script file. You can do this by right-clicking in an empty space in your Visual Studio Code editor and choosing New File. Alternatively, as another example, you could create a file using touch command by opening Visual Studio Code terminal and writing touch followed by the file name. To open Visual Studio Code terminal, you can tap Ctrl tilde on your Mac or go to View Terminal. Or, of course, by any other means if you're not using Visual Studio Code editor. I'm going to create a file through the editor and name it script.pl. The first thing to note is that you end your Perl script files with .pl extension. I will start out by writing the full basic Perl file structure, and afterwards we will go into detail of what each line means. So let's begin. Hashtag, exclamation mark, user, bin, environment, Perl, use strict, use warnings, print out. Hello, world, semicolon, 1, semicolon, and new line. Okay, a lot of things are going on here for a very basic Perl script file, but don't worry, we will go through each line and explore in detail what it means. Before that, let's quickly see how we can run this file. If you go to a terminal and type Perl followed by the script file name, which in this case is script.pl, you're going to see Hello World printed to your console. This line comes from the print statement we added in our script file. But what about the other lines? Well, the first line at the top is called shebang line, and it basically tells your system how to run this file if the file is set as executable. You can run your file as executable if you go back to your console and type /script, which is our Perl script file name, and press return. By default, you're going to see a warning that says permission denied, and that is because currently our file is not set as executable. You can see this by typing ls for list minus la and our file name, which is script.pl, and what we see here that our file is currently set as read and write. What we're missing is the executable tag. To set your file as executable, you can write chmod, which is for change mode, plus x and the file name, which is our script.pl, and press return. Now, if you type ls minus la or script name, which is script.pl, you're going to see this new x tag, which means this file should now be executable. If we try to rerun /script.pl and note that we did not add Perl before the script file name, is going to print hello world. The interesting thing is that if we remove the shebang line at the top of our file, we save it, go back to our console, and try to run our script as executable, it's going to complain. This is because our system does not know that this file should be executed as a Perl script and tries to run it as a bash script. Therefore, it complains that the content of this file could not be parsed. And that is the meaning of the shebang line. It basically tells your system how to run this file if your file is set as executable and you did not explicitly specify that it should be run as a Perl script. So if we'll add this line back, we save it, we rerun it, and it works again. The next two lines starting with use are called pragmas. There are various pragmas in Perl, however, the most standard ones you should always be using are use strict and use warnings. In essence, these statements enforce you to write robust and less error-prone code. They give you warnings and even compile time errors when you are trying to write Perl code that can cause ambiguous results. Let's test this by firstly commenting out the use statements. In Visual Studio Code, you can highlight multiple lines of text and tap Command /, which is going to automatically comment your Perl code. Next, let's try to join our hello world string with a variable in our print statement. And don't worry if this looks confusing. We will look at variable types in our next lectures along with concatenating and interpolating variables in strings. However, let's just focus on the fact that this strange variable came out of nowhere. It has no value and we're trying to randomly append it to our string with a dot notation. What we're doing might seem wrong and ambiguous. And that is because it is. We should not be able to use something we haven't defined in our scripts. However, Perl is not going to complain unless you tell it to complain. If we try to rerun our script with explicitly saying Perl, or script name, which is script.pl, is going to say hello world. And this is where the strict and warning pragmas come into play. It will explicitly tell our Perl script not to allow such ambiguity in our code. If we uncomment warnings and try to run our code again, we're seeing more output. And this output is main test used only once, main referring to our package, which is this file, possibly a typo on the script PL. Yeah, close enough. And it says use initialized value $test in concatenation. And that is true. We are using an initialized value in concatenation with our string hello world. Now, if we try to uncomment strict, save the file, run it again, so Perl script.pl is going to say global symbol test requires explicit package name. Did you forget to declare my test? Well, yes, we did not declare my test variable. And then it says execution of script.pl aborted due to compilation errors. And this is great. Now, instead of just giving warnings, our script actually bails out and says, no, I don't know what this variable is. I don't want to proceed compiling this. I don't want to run this. Please be more explicit with your code. Now, let's try to define our variable before using it. So if I say my test equals a random value, which is a random string, and we save this. And I understand if this might seem confusing at this point because we haven't looked into variables and how you define them. But a short summary is that basically we have this simple scalar, which we're going to look into next lectures, that we assign a string, which is called random. And then we try to concatenate it with our hello world. Now, when we have explicitly defined our variables and we try to rerun our code, is going to succeed. What we're going to see now is our random, which is the test variable, concatenated with hello world. Now finally, the print statement, as you probably have guessed by now, simply prints out a text to our console. Lastly, we are returning a number. This is a standard for Perl scripts, but not necessarily always present. It's common to return a truthy value in your Perl scripts to indicate that the compilation of your Perl script succeeded. If you have a standalone Perl script, as we do now, the truthy return value will probably not be in place. However, and we will look into this in use versus require section, if not set, the script will throw a warning when you are using a Perl script in another Perl script. So that's it for this lecture. We looked at the basic Perl script file layout and what is the meaning of the shebang line along with the strict and warning pragmas. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video we're going to explore one of Perl's data structures, scalars. Let's begin. So, what are scalars? Well, scalars are a single unit of data, meaning they can hold one-off, undefined, number, decimal number, string, or reference, but don't worry about reference for now. You define a scalar by saying my $, let's say test equals 1. So we assign a number of value 1 to a variable scalar named test. As mentioned before, you can also assign, let's say my string equals hello, and as well as assigning my decimal equals 1.22. So one thing to note is that scalar names are unique. So if I try to say my test equals 1, save this, and I try to run it in my console by Perl script.pl, is going to say my variable test marks earlier declaration in same scope. And what this means is basically it's saying that, looks like you did define a variable named test, and you're trying to define a variable which is called test again. You might be doing something wrong. And in this case, this is quite true. We are defining my test variable twice, and it does not make a lot of sense. On that note, it's worth mentioning that the variables are also case sensitive. So if I said my capital test equals 1, save this, run the Perl script.pl, I'm going to see no warnings. And this is because I have a test variable defined with a lowercase t and another variable called test with the same value but defined with capital T. So technically the variable names are not the same because one is with a lowercase t and the other one is with the uppercase t. Let's look at some variable operations. Let's start out with the numbers. For example, I'm going to remove string for now, and I am going to print out a test plus decimal. Go to console, print it out, I'm seeing 2.22. So what we did there, we added test variable value 1 with decimal variable value 1.22. And what we got in the end is 2.22. We can also do the same thing with the subtraction. So if I say test minus decimal, I go back to the console, I rerun the script file, what I'm going to see is minus 0.22. And that makes sense because 1 minus 1.22 equals minus 0.22. You can also do multiplication, which is 1 times 0.122. Rerun this, and it's the same as 1.22. And you can do division as well. So test, which is 1 divided by 1.22, go to the console, rerun the Perl script file. You're going to see a very ambiguous number, but let's just assume this is right. Probably it's going to make more sense if we say test equals 20, and we divide it by 5, which should give us 4. And yes, here we go. We see number 4 printed out to our console. Now let's look at the strings. Let's reintroduce our variable named string equals hello. There are a couple of things you can do with the strings. For example, so if I have a string variable, so variable named string and number 2 equals hello 2, I can print out string and concatenate it with this dot notation with string 2. Save this, rerun our Perl script file, and I'm going to see hello concatenated with hello 2. So another thing I can do with strings is I can interpolate them. For example, I could convert string 2 with double quotation marks and say hello 2 space string variable, save this, and I'm going to replace the print statement with only string 2. Save this, go to the console, run Perl script.pl, and I'm going to see hello2 value, which comes from here, space, and the value of string. You can also use special variables in your strings, such as a break line. You might have noticed that in our console, usually when we run our script, we're going to end up with a terminal input at the end of what we printed. It's not quite great. So what we probably want to introduce is a new line. And how you can add a new line is by adding \n. We save this, we rerun our script, and what you're going to see now, this is the value we printed out, followed by new line. So my terminal input is on the next line. One thing to note, this is only usable when you're using double quotes. This will not work for single quotes. What I mean is, if I would say \n in my variable string, and I would try to print this out, what I'm actually going to see is the hello2 value, which we see here, and the variable hello, which holds hello \n, which is just a string. So you cannot use these special variables in strings which have single quotation marks. You can also use special variables such as \t, which stands for tab. We rerun our Perl script file, and what we're going to see is there is a slight extra break here, but it's not that quite visible. So if we add, let's say, 2 more backslashes, T, and rerun the file, yes, this is much more visible. We can see that we have inserted tabs here. So let's try to concatenate a number with a string. So I'm going to remove this string too, and I'm going to say my scalar, and let's call it a number, just a scalar name, equals 1. And we try to print out string concatenated with variable number. Let's also add that break line here, which is \n. And let's run this. So Perl script.pl. And what we're going to see here is the hello value, which is in the string because we left the \n here, and followed by number 1. So when you're trying to concatenate a string with a number, Perl is going to be smart enough to understand that what you actually want to do, you want to convert the number to string and concatenate that together. But what happens if we try to, let's say, sum variable number and variable string? Let's do that. Let's replace string dot notation, for which is concatenation, with plus, and let's still leave the dot \n for the new line, and let's save that. Let's go back to the console, rerun it, and it's going to say argument hello isn't numeric in addition. So this means that Perl is smart enough to figure out that you're trying to use a number which is in variable number, and you're trying to add it to a variable called string, which holds a string, and it doesn't seem quite right because you are trying to sum up a string with a number. One final thing to add is, for example, if you wanted to print a double quoted string, such as hello, and use a variable, let's say number, but you don't really want to print out the value of this variable, but you literally want to say hello $number. So you can do this by backslash before the variable sigil, and it's going to escape your variable in the double quotes. Let's save this, go back to the console, save Perl script.pl, and here we go. We see hello $number. So this variable, number 1, wasn't interpreted inside the double quoted string. So hopefully it's a lot clearer what is a scalar in Perl, how you create and assign values to scalars, including doing some basic operations such as adding numeric values and concatenating strings. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. Before we move towards exploring other data types in Perl, I would like to introduce you to an alternative and much better way to debug your Perl code instead of using print statements. This alternative is using a module called Data Dumper, and how you can use it is by saying use data dumper semicolon. To note, you do not need to explicitly install this module as long as you're using Perl version 5.36 or above, meaning this module is part of Perl default core modules. And to be more precise, the data dumper module should be available from Perl version 5.20. Later in this section, we will explore in more detail how to install and use modules, along with how to use statement works behind the scenes. However, for now, the key takeaway is that when we write this use data dumper, we get access to a powerful debugging method called dumper. And how we can invoke this is by saying print dumper, opening bracket and closing bracket, and ending with semicolon. So everything what we put in between the bracket is going to get debugged in our terminal. So basically, this method, aka dumper function, takes a list of arguments and will print out detailed information about the given data. Let's try it out by printing some data about scalar variables. I'm going to introduce a scalar, a variable called a, which is going to hold a string, and it's going to say hello, ending with semicolon, and I'm also going to introduce a variable called b, which is going to hold a decimal, let's say 22.32. and then that. And now I'm going to add these variables in between the dumper function. So $a, $b, save this, go to the console and write Perl script.pl. And what I'm going to see is this var1 currently holds hello, and variable 2 holds 22.32. And what this refers to is that variable 1, var1, is the position of the variable being debugged. In this case, the var1 refers to $a, which holds a value of a string which says hello. Now the var2 at position 2 holds a value of 22.32, which we can see here. You might be thinking, well, this does not differ much from what we saw in our previous lectures using print. And you are right. At the current time, it does not differ much. And that is because we're using basic data types such as strings and numbers. However, the real power of this debugging module will become much more apparent the more we use it in our future lectures with more complicated data structures like arrays, hashes, and references. So this is it for this lecture. We looked at how we can use the data dumper debugging module. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video, we're going to explore the second Perl data type, array. So what is an array? Array is a data type that holds ordered list of values. These values can be strings, numbers, decimals, and references. But as before, don't worry about the references at this point. Quick note, list and array are often used as if they're the same, but the list is the data you assign to array, and the array is the actual variable. How you can create an array is by saying my, @ test equals parentheses and semicolon. Let's try to debug it now as we did before. So let's say print dumper, and in between there we're going to add our test. We're going to end it with semicolon, go back to our console, say Perl, script.pl, and we're going to get nothing. And this is normal because we haven't added anything into our array yet. So let's do that next. Let's introduce a couple of values, such as a number, let's say 22, a string, which is going to say hello, and a decimal, let's say 1.22. Let's save it up. Let's go back to our console. Let's rerun the Perl script.pl. And what we're going to see now is that the variable remembered on the left-hand side, these are positions, 1, 2, 3, and the values being 22, hello, 1.22. So what happened here, since this is a list, we got all the elements printed at their positions as we have defined in our list sequence. So variable 1 is 22, variable 2 is hello, and variable 3 is 1.22, such as we can see here. Now, alternative way, if you're using with only strings and single words, what you can do is you can use this keyword called QW, which is for quote word, and followed by forward slashes and say 1, 2, 3. Now, if you debug that, we're going to see 1, 2, 3. And this is quite a handy shortcut instead of using parentheses, quoting your strings. If you only need strings in your list and those strings are not separated by spaces, such as 1, 2, 3, and then you want to add a single string which is my 4, what you end up with is actually 5 items in the list. So 1, 2, 3, my being a separate item because it's separated by space, and then followed by 4. Now, in order to access our items in a list, and I'm going to remove this my keyword, so we have 1, 2, 3, you can use $, followed by your list name, which is going to be test, square bracket, and the position of an element in your list. Now take note here that all the positions of items in an array starts at 0, meaning the string 1 is going to be at position 0, string 2 is going to be at index position 1, 3 at index position 2, and 4 at index position 3. It might seem confusing, but basically just think about it. How many items you have in your list, just add -1, and that's how you can access it. So for example, if I wanted to access, let's say, string of 3, I can do $test square brackets and index position of 2. Save this, go to the console, I print it out, which is Perl script.pl, and here we go. We're going to see variable equals 3 because we're accessing the index position 2, which is 0, 1, 2, and holds a string of 3. You can also override items in your list by using the same notation of index. So let's say I'm going to remove this. I'm going to still print out the test, and I'm going to say test. And let's say I want to override the item at position 3, which should be our string 4. And I want to say that this is now override. Save this, go to our console, print it out. And what I'm going to see now is 1, 2, 3, and override, because we override the variable which is at position index 3, meaning 4, with a new string, override. Now the interesting thing is that let's say I wanted to add an item at position 10. So I'm going to say test position 10 is override. Now I'm going to print out the list. And what I'm going to see is now that we have 1, 2, 3, 4 represented by items here. And then we have these undefined values that we looked at in the previous lecture, which means it has no value at these positions. And then the 11th item, which is -1, index 10, is override, which we just set now. Now, what if I wanted to access this last item in the list? So instead of needing to know how many items and the index positions I have in the list, what I can do, I can say -1. And actually, let's say that I wanted to not introduce a new item at position -1, but I'm going to say test, and I want to access -1, which should be the item 4 at the end of the list. If I save this, print this out, and here we go. I see variable position 1 is a value of 4. The same goes if I wanted to access -3, is going to be 1, 2, 3, which should be value of 2. I save this up, and I debug this, and I see that the value printed out is 2. A little bit confusing, because if we want to access items at the end of array, we actually need to start at position -1. If we want to access items from the first position, it starts at 0. It's just something to keep in mind. Now, another thing you might want to know is how many items you have in the list. And the way how you can do this is by saying let's say, define a variable size equals at test. Now, if we print out the test, go to our console, we're going to see that, oops, we have we actually have the variable defined as size. Apologies, we save this, we run the Perl script again, and we're going to see that it's 4. And that's right, because we have 1, 2, 3, 4 items in our array, which is called test. Now here what happens is that since we're trying to assign a list to a scalar, we're actually implying a scalar context, right? Because a scalar can hold a single unit of data. It cannot hold a list. So what it's going to do is going to take the list size and assign the number of items to this size variable. So another thing you might want to know, you want to know what is the last index in our array. The way how you can do this is by saying last. Let's say, let's define a variable of last index equals $hashtag, and it's going to be the name of our list, which is test. And now if we print out last index, we go to the terminal, Perl script.pl, we're going to see 3. And that is correct, because the index is 3. We have 4 items, as we debugged before, but the last index is 3, because we start at 0. So 0, 1, 2, 3. Now let's look at some very useful methods how we can quickly populate arrays using sequential numbers or letters. Let's say I want to populate my list with numbers from 11 to 30. You can go 1, 2, 3, 4, and well, I mean, that's actually 11, 12, 13, and so on. But there is a shortcut and a much quicker way. You can say 11 ... 30. Now we save this, and what we actually want to print out is this list. We override that, go to console, print it, and what we're going to see is that our array get automatically populated with numbers from 11 till 30. So all the way down from here at position 1 up to position 20. You can do the same thing with letters. Let's say I wanted to populate the array with letters from A, 1, 2, to Z. I go to the terminal, I print this, and here we go. A, B, C, D, so on, and up to Z. And you can of course also do like age and just go to N. You go to console, print this, so G, H, I, J, K, L, M, N. So let's say I only wanted to access specific elements in my list that contains numbers 1, 2, 3, 4. I can do this by saying the variable name, which is array name test, and I can give index positions. So if I wanted to access only the elements 3 and 4, I can go 0, 1, 2, 3. So if I say 2, ... 3, save this, say Perl, script.pl, I'm going to see 3 and 4. Because index position 2 is 0, 1, 2, and index position 3 is 4. There are 4 commonly used methods when working with arrays. Let's explore them in more detail. Let's keep our list in a place, and let's say I just want to debug the list itself, and I'm going to write them out, the methods which are commonly used, which are push, pop, shift, and unshift. So what the push does, it adds an element at the end of the array. For example, if I say push, you provide the array name, which is test, and let's say I wanted to add number 20. Save this, and I print out my items, and I see 1, 2, 3, 4, and our new item, which is 20. Now pop removes an element from the end of the array. So if I say pop, array name, which is test, and save this, and I reprint, I'm going to see 1, 2, 3, 4, which is just our original list. Now shift is going to remove the first item from the list. If I say shift, add test, save this, rerun, and I see 2, 3, 4 because our item 1 got removed. Now unshift is going to do the opposite of shift, which you can imagine is it's adding an element at beginning of the list. So unshift, let's say at test 20, save this, and reprint, we're going to see 20, 2, 3, 4. So because we pushed an item on the list, we removed an item from the end of the list, we shifted an item from beginning of list, which was 1, and then we added an item at beginning of the list, which is 20. So another useful thing you can do with your list is sort them. And by default, Perl has this sort method, but it works with strings by default. So let's look at example of sorting strings using sort method. So I say H, O, P, M, L, A, B, C. Space here. Apologies, looks like I'm missing a space. So to sort this list, you want to say at test, you want to replace this list with a sorted value, which is sort, and you simply provide a list. Because as I mentioned, the sort method by default works on strings. So if we try to sort this test list, we should get back the expected results. So let's save this, go to our console, say Perl, script.pl, going to be ABCD HLMOP. That looks all right, because we had HOPM and so on, and this does look like a sorted list of letters. Now, what if we want to sort a numeric list? So let's remove this. Let's introduce 4 to 10, 22, and maybe 30. If I try to say test, sort, test, and print this out, so something does happen. It says 10 to 22, 34, but it does not look quite what we would expect. And this is because it's actually sorting these numbers based on a string context. What we want is to explicitly define a function after the sort method, which we're going to say A, being the first element what we received in this method, this comparison symbol, which is also referred to as spaceship symbol, and value B, which is the next item we're going to iterate over. I save this, go back to the console, and I print this out again. And I see 2, 4, 10, 22, 30. You can also reverse this by saying B and A, save this, reprint, and it's going to be 30, 22, 10, and so on. In the next lectures, we're also going to explore additional methods as join, split, grep, and map in Perl built-in function section. So these are definitely by any means the only functions we have to work on lists. So this is it for this lecture. We looked at what are arrays in Perl, how you create and fetch values in arrays, and we also looked at basic methods to interact with arrays in Perl. I hope you found this video useful, and I'll see you at the next lecture. Hi there, and welcome to this lecture. In this video, we're going to explore the final Perl data type, which is called a hash. So what is a hash? A hash is simply a set of key value pairs. You store and access your values in a hash using keys. The values in the hash can be strings, numbers, or references, but as I have said, you don't need to worry about references at this point. Hashes are an excellent solution if you need a fast lookup of values if you know the key. Think of it as a phone book, but faster of course. So basically, you have person's name and you would like to look up their phone number. You can have thousands of entries in a hash and quickly look it up using a key. Let's look at example to make this clearer. To declare a hash, you can say my %, let's call it a map, equals parentheses. Now let's try to debug it. So print dumper and or hash. Save it. We go to console, Perl, script.pl. We're going to see nothing. So as before, since we don't have any values, we are not seeing anything in our console. Let's change that. Let's say I wanted to add a key, which is A, that's going to point to a number, let's say 20, a key B, which is going to point to a string, which is hello, and key C, which is going to point to 11.22. If I save this, go back to the console, and I rerun the Perl script, what I'm going to see is actual list values. So positions being 1, 2, 3, 4, 5, 6, A, 20, C, 11, 22, and B, hello. And this is because technically hash is a list that has elements following order of key, comma, value. Now the thing to note is that this list is never going to have the same order. As you can see already here, we have item A with value 20, as we have defined in our hash. However, the next value is C, 1122, which should be B, hello, and it's not the case because the order is never going to be preserved in a hash. So if I rerun this again, I'm going to see C, 1122, A20, and if I rerun, you can see as before, the order changes all the time. If we want to access a specific key in our hash, it's very similar to array. So we're going to use $, the name of our hash, which is map, but instead of using square brackets, we're going to use curly brackets. So like this, and then we're going to give our key, which in this case can be, let's say C. We save this, we rerun, and we see now what we debug, the variable 1, which holds a value of 11.22. If we want to set a new value, we can do the same thing, very similar to arrays. But we're going to use $map instead of square brackets, we're going to use curly brackets, and instead of the position of an element we want to add, we're going to say we want to add a new key, which is ABCD equals new. Now, if we print out the D key, we're going to say new. One important thing about hashes is that the keys are unique, meaning you cannot have more than one key with the same name in your hash. So what I mean by that is that if I remove what I debugged before, replace it with our hash, save this, and let's say I wanted to add C equals 2 and C equals, let's say, a string new. I save this, and I debug my hash. And what I'm going to see is that C holds the value of new. And this is important because we have 3 key value pairs in our hash, but what is preserved is the latter value in the hash. So all the keys which come before the final key with the same name is going to be overridden, meaning this is our original key, which was overridden by C with value 2, and then overridden again by C new. On the same topic, it's worth mentioning the keys are unique. So what you could have, you can have a capital C, which points to a value new. If we save this, we print out our key value list, we're going to see capital C equals new, and alongside that we're going to see our lowercase c 11.22. As for the key names, you can have letters or numbers or underscores in your key names. However, once you want to start introducing special characters such as %sign or a space, what you need to do, you actually have to wrap your key name with a quote. So if we save this and we debug our hash, we're going to see our key of 1 underscore %sign space holds a value of new. And if we remove these quotes and save this, well, you might imagine this is probably going to be invalid syntax. And that is true, because we see misplaced underscore syntax error at %sign, and it gets very confusing. Something's very, very wrong. Another useful thing to know is that you can merge two hashes together. Let's say I have my map with some values, and let's remove this one, which is breaking our script. We save this, and let's say my map2 equals new hash, and I'm going to say I have keys low, which points to number 1, and I'm going to add %sign and map. Save this, and I'm going to debug map2. So what we're going to have here is our original keys pointing to our values plus the hello 1, which is going to point to hello 1. And this is how you can merge multiple hashes together. And you can even explicitly override the values in a hash, saying, I want the C to be new. By debug, the C holds the value of new now. So what happened here, we had our original hash, we merged it into the second hash, we spread the values, so to say, and then we override the value of C, which is 11.22, with a new value, which is string new. So similar as with arrays, you can also access slices of hashes. For example, let's remove the second array and let's print out the first array. Let's save it, and how you access specific slices of a hash is by using @ symbol before your hash name, curly brackets, and then the name of the keys. For example, if I wanted to access A and C, I would say A, C, save this. And if I print out, sorry, I had to use the quotation marks. And if I print this out, I'm going to see value of 20 and a value of 11.22 because I'm accessing slice of A with value 20 and slice of C of value 11.22. Now let's explore some very useful methods that's going to help you to work with hashes. So one of these methods is called keys. And as you can imagine, it does exactly that. It returns the keys of the hash. Now let's say I want to introduce a new array, which is my array. And I'm going to say keys %sign map, which is our hash name. Save this. And what I'm going to debug is the actual array named array. And we go to our console, we print this out, and we see BAC. And because the keys method returns all the keys of a hash, and the hash keys are never sorted, they're always changing, we're going to get back random order of the keys. So we started with B, A, C, now it's A, C, B, and so on and so on. The keys method is also very useful if you want to get the size of the hash. So my size equals keys and the name of the hash. Now, very similar to what we saw with array is that here we have scalar context, and we say, I want to see how many keys there are in the map hash. So we're going to get back all the keys in this map, as we saw before, but we are imposing a scalar context. So this becomes a list where the scalar context is imposed. So what we should get back now is the amount of keys, aka the size of the hash, which is 3. So another thing is that, for example, if you want to see if a key exists in a hash, but you want to avoid checking condition where it could be false, for example, ABCD equals undef, you can use a keyword called exists. And how we can check if the key exists is you can use a ternary expression. And don't worry about this now. We will look into ternary expression later on. But basically, we can check the existence of the value by saying exists is just a scalar name equals exists. This is the function where we say or map hash. Since we try to access a value, we use dollar notation. We want to check for key, which is called D. And the ternary statement goes with question mark, which says, is this first expression true? If this is true, then we say yes. And then you use colon, which is if this expression is not true, which is going to call the string of no. Now we can print out the exists. Save this, go to the console, print it out, and it says yes, it does exist. If we wouldn't use this keyword, and we remove the exists, we print it out, it's going to say no, because, well, technically our key does exist in our hash. However, since we are checking on a truthy context, and in Perl, undefined is not a truthy. Truthy value would be 1 or a string or a positive number, but in this case we're using undef, which is not truthy value. And that's why the exist keyword is quite useful, because it says, okay, well, do we have the key? We don't care about the value, but do we have it in our hash? And in this case, yes, we do have it. If we say, do we have a key of Z? Save this, print it out. No, we don't have a key of Z. And the final useful method worth mentioning is delete. I could delete items from my hash. And how I can delete items from my hash is I'm going to remove this statement. I'm going to print out my hash. Save this. I can call delete. As before, we use dollar notation to access a single element in our hash. So I'm going to say $sign map. And I can say delete C. I save this. Rerun the script. And as you see, there's no more C here. So we have D, B, and A. I can repeat this line by saying also remove A and also remove D. If I reprint this, here we go. We only have B left in our hash. This is it for this video. We looked at what are hashes in Perl, how you can create and access values in a hash, and we also explored basic operations on the hash structure. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video we're going to explore what are references. I've said multiple times in previous lectures that you should not worry about references. However, that has changed. We have come to the point where we do have to worry about references. But don't feel intimidated. The more you work with references, the more it becomes clearer what they are, how they work, and how extremely powerful they are. So, what is a reference? Well, reference is basically a location in memory which points to another data structure, such as array, hash, or scalar. Reference allow you to construct nested data structures, such as hashes where keys point to nested reference like array or hash reference, or arrays that contain reference to hash or array reference at set position. I understand if this all sounds confusing, but don't worry. Just think of it that previously when we were merging arrays and hashes, we could not be able to point a key to a hash because our hash gets automatically merged in our, so to say, normal data structure, which is array or hash. With references, you can actually nest the hash structure or array structure, which can be very, very useful in a lot of scenarios. You might have also heard of a term passing by value or passing by reference. When you pass data in your code using value, you're duplicating the data in memory and allocating new memory space for your values. When you pass by reference, you're actually passing the location of data structure in memory instead of copying the data. Passing by reference can be extremely useful if you want to work with the same data reference in your code instead of constantly copying your data all over. Let's look at some examples. What I have in front of me is a simple hash, which is named hash, and it holds a key A and B, which points to values 1 and 2 respectively. I also have array, which is defined with this quote word syntax and holds string 1, string 2, and I have a scalar, which simply holds a number, 32. Now to get references to these values, we can use this special syntax, which is using a backslash before your data structure. What I mean is, if I try to do print, I can say backslash hash, save this up, go to console, run my Perl script.pl, and I'm going to see this strange value. And basically, this is a reference in memory. It says that what we're printing out here is a reference in memory instead of actually printing out a hash. You could try to print out a hash as it is, like this. We're going to see B2A1, which is basically a list printed out. B being the key, and 2 being a value, and A a key, and 1 a value. The same would be with array, right? So if we say array, if we print out array, we're just going to print out the values there, string 1, string 2. Now, if we add a backslash before the array, we're actually going to see this syntax. It's going to say, hey, what you're working with here is array references, and this is the point in the memory for this reference. And this point in the memory is not going to change. So if we say, for example, print many array references, we're going to see that, maybe let's add a new line character so it's better formatting. So what I'm doing now on Mac is I'm pressing Option, Command, and down arrow to select multiple lines, space, double quotes, because we want to use special characters, and N, save this, go to the console, print it out, and you're going to see that all of these values are actually the same. It says it's a hash ref, and this is the point in the memory. We printed it out many times, but it never changed, because this array has been already allocated in the memory, and all of these references are pointing to the same allocation of the data structure. Now, let's look at some example where we are assigning a reference to a scalar. Then we are trying to modify that reference. Let's do this. Let's create my ref1 equals backslash. Let's choose array and do my ref2 and backslash array. And let's do this. Let's try to push something on this reference 1 because, well, it should be a hash. Ref1 and let's say string new, just for new string. We go to console and we try to run this. It's going to say, oof, you're trying to push something on a scalar which is forbidden. And the thing is that when you're trying to manipulate references, you always have to dereference your reference before working with them. So basically what it means, you have to get the original data structure back in order to push or pop or access an element and so on. So referencing was using backslash before our data structure. Dereferencing is, well, you can actually do it many ways. One of my preferred ways is I use arrow syntax as such, and then I say that this is array, and you use this asterisk. You save it, and you try to run it, and it didn't complain because we are dereferencing this and trying to push a new string, which is fine because we can use push method on array. Now let's also do this. Let's try to print out what we are actually getting back in array. So print dumper, and let's print out the array. Let's save this, go to the console, run this again, and here we go. We see string 1 and string 2, and we also see our new value. So as you can see, we pushed onto a reference that we dereferenced so we can, push things on it, and we added a new value. And now we have 3 values on the array. We could do the same thing for reference 2, right? We could try to push, let's say, new 2. Go back to console, print this out, and here we go. So we have our 2 original values in our array, which were defined here. Then we have references, reference 1, reference 2, apologies, which points to the same data structure in a memory. So basically reference 1 and reference 2 hold the same pointer in memory that says, hey, this is this array, and then we are using this reference to say, hey, add this value to this structure in memory. And the same for reference 2. It's exactly the same pointer as reference 1. So we're just adding a value new to our array. So as you can see, all scalars that point to that reference when edited will affect the original data structure. Now we looked at how we can get a reference from existing data structure. Now let's see what happens if we are debugging these values with data dumper using references. So here I have my array again. I backslash it as we did before to get a reference in memory, and we print it out. And you're going to see that instead of value 1 and value 2 being printed out with position var1, var2, we're actually printing out a position var1, which holds this square brackets having 2 elements inside of it, which is string 1, string 2. So this indicates that we're working with array reference. The same thing if we did with hash reference, %, hash, save this. What we're going to see now, instead of list items of key being, let's say, var1, pointing to var2, which is the value, you're going to see the hash reference is included in curly brackets, a1 and b2 being our keys and values. Now the same thing goes for the scalars, so you can say scalar and print that out. And instead of seeing just the value 32, we're actually seeing this backslash, which indicates we're working with array reference. Now, it's worth knowing that you can construct reference the same way how you can construct a hash or array. And the way you do it is using the syntax as it was printed out in data dumper. So I'm going to get rid of these values. I'm going to say my hashref. As we saw before, we need to use curly brackets. And let's say add a key hello 1 and rolled with value 2. If we print this out, you're going to see this is a hash reference because we're using these curly braces instead of just parentheses. So we're working with hash references. The same goes with arrays. So let's say I wanted to construct a array ref. And what we saw before being printed out by data dumper was these square brackets. So that's the same thing. To construct array reference, we can say number 1, 2, 3, save this, and print out the array ref. Look at the console, and here we go. So our square brackets, 1, 2, 3, and closing square brackets. Now how can you access items in your references? I'm going to go back and introduce the hashref with values of a key pointing to value 1 and b pointing to value 2. Save this up. What if I want to access, let's say in hash reference, only the key a? It's very similar as you would work with hashes. In hashes, you would say hash ref, and then you use the curly braces to access element a. However, what you need to do when you're working with references, you always need to dereference them. And one of the way how you can dereference is by using this arrow notation. So you can access key a, save this, print it out, and here we go. We can see that this is number 1. If we wouldn't use the arrow syntax, if I get rid of this, save it, try to rerun the script, it's going to say, hey, looks like you're not using dereferencing syntax and you're accessing a hash somewhere, but I don't see this being defined. Did you forget to define hashref? Well, technically, no, we didn't forget to define it. It's just we didn't want to access a hash. We wanted to access a hash reference, right? So this is why we need to dereference using this arrow notation. The same goes for if I want to access an element with array, within array. So I would say array ref, arrow syntax, square brackets, as we saw before with arrays, and then we access by index. So if I wanted to access item with value 2, which is at the index position 0, 1, I would type 1 here, and I print this out, and I see value of 2. Because the same as with arrays, array reference, items are indexed starting at position 0. So 0, 1, 2. So if you're accessing index 1, that means we're getting this element. So what if you wanted to dereference your whole hash? You can do this in many ways. You could say hashref, arrow notation, %, and asterisk. Save this. We go to our console, print it out. And here we go. We saw that same pattern of elements being key value printed out. It's exactly the same for array ref. However, you would replace percentage sign with @ symbol. Save this and go to the console, print it out, and items 1, 2, 3. But remember, you create a reference or get a reference in memory for data structures such as array, hash, or scalar by using backslash. But if you want to convert back from array reference into the data structure, you would use dereferencing, not referencing syntax. Alternative dereferencing syntax would be using the symbol before the $sign. Save this, we rerun it, and we see 1, 2, 3. And yet another way how you can dereference is you can use @ for what is the original data type, curly brackets, and ending curly brackets. If we run this, it works. Now, I mentioned previously there's a thing about references, specifically hash references and array references, that you can create nested structures. So let's explore that. Let's say I have a key A pointing to 1, B pointing to 2, and what if I wanted a key C that points to another hash reference, or a hash structure, so let's say. It's possible with hash references. So basically, what you're doing here is you're pointing to a reference in memory, right? So you're not kind of merging your structure in. You can say AB is pointing to numbers and C is pointing to reference. So you can say new equals 1 and new 2 equals number 2. And if we try to print out the hash reference now, so hashref, save this, print it out, is going to say, here are my original values and here's the new C value we added. It's nested, and we can also introduce more nested values, such as deeply can point to, let's say, array reference with values 3, 4, and 5. I save this, I print out my hash, and here we go. Our key is now pointing to hash reference. And as I mentioned before, this can be extremely useful when you need to store information in object pattern, where keys are pointing to various types of data or information about the object you're working with. The question is how, for example, we could access the value of C, so the key C in that hash reference, the value of key new2. So what you could do is the same thing as we looked at the dereferencing, is you use arrow syntax, you say key C, and then you keep dereferencing with arrow syntax, saying my new key 2. If I print this out, we have the value of 2, which is under the key new 2. The same thing if I want to go deeper and say, I actually want to access the deeply key, which holds array ref. So since we know it's array ref, what we need to do is we use the same arrow notation and we access the value by index. Let's say 2, which is going to be 0, 1, 2, meaning it should be value of 5. We save that, rerun it. Oh, and looks like we have syntax error. So we are accessing our hashref key C, which is here, and then we say there should be a deeply key on the new 2, which is actually pointing to value of 2. What we need to do, we actually need to access the deeply on the C structure. So if we change that, we rerun it, and here we go, the value of 5. And the same goes for arrays. So if we wanted to add nested data structures, such as is my array ref, and I'm going to say, first of all, it's just going to be 1. The second one can be a hash ref. And we're going to use this quote word syntax, which we're going to spread in some strings into the second element, which is A, B, and C. The third element can be a hash ref, which says A with value 1. B can be a nested hash ref, which has a key C that points to hash ref, that let's say has an element of hashref again with a key A pointing to a new hashref, and so on and so on and so on. But you get it. The point being is that when you're working with hashrefs, you can nest the data structures as much as you want. If I try to print out this structure, which is array ref, and I save this, here we go. We have first items, index position 1 is value 1, then it has a hashref with these 3 strings, A, B, C, and then we have this nested structure, which is A holding a hashref value. And if we try to access this, and let's add a value, for example, like find me. So it's going to hold 2 strings, find and me. So let's look into how we can access this structure. So we're going to start with dereferencing 0, 1, 2. So it should be at index position 2. We move forward. We want to access a key, which is B. So we type key B. We then want to move deeper, access the key C, And the key C is actually pointing to a array ref, which we can see here. And the first element is a hash ref. So we access the first element and we know this is a hash ref. And then we dereference that, and that one has a key A. And if we save this and print out, and here we go, it's going to say find me. Now, some of the very useful methods you can use when you're working with these references is called ref. So let me just clear this up a bit and let's leave the hash ref only. So you can use this function called ref, which takes a value in between it, and you can add hash ref. And what's going to tell you is that you're currently working with a hash ref, right? So ref tells you if the data structure you're working with is a reference. In this case, yes, this is a hash ref. You could be passing in array ref, save this, and this is anonymous array ref. We are not assigning it to a scalar, but that's fine. You can have anonymous references not belonging to any scalar. If you do this, it's going to say this is array ref. The same, of course, goes for scalar ref. You can use the same methods on references as you would use on your hashes or arrays. However, you always need to dereference your structure. What I mean by that is, for example, if you wanted to say keys on your hash ref, save this, but the console is going to say you're trying to use keys on scalar and that's forbidden. And you can easily avoid that by just saying that we want to dereference it by some of the ways we looked at before, for example, array notation, percentage sign, and star. So we save this and we run it, and here we go. We see keys BAC. The exactly same thing would be for if you wanted to call the values. You also need to dereference this. So delete things such as hash ref equal, let's say we want to remove B key and we print out just the hash ref. Here it is. You have the key C and only key A. So B was deleted. The same would be, for example, if an element exists, but remember, you also need to dereference it with this arrow notation. So this is it for this lecture. We looked at what are references, how you access and interact with references, and why they are extremely useful. Hi there, and welcome to this lecture. In this video, we will learn what are subroutines in Perl and how we can use them. And we'll also look into Perl subroutine signatures, also known as passing named subroutine arguments. Let's begin. First of all, a subroutine is exactly the same thing as a function. It's a group of statements encapsulated in a single function to perform a specific task. Subroutines, aka functions, are extremely useful in any programming language to encapsulate and reuse logic in your code. Typically, each subroutine is written so that it accomplishes a very specific task. Let's look at how we can use subroutines. To define a subroutine, you can use this keyword called sub, followed by a space, and then your function, aka subroutine name. I'm going to call my function test, and the logic that should be executed by the subroutine is in these curly brackets. We have written our first function. If I go to the console and try to run my script, which is Perl script.pl, I'm going to see nothing. And this is because, well, we have defined our subroutine and it is a valid context, but there are two issues. First of all, it doesn't do anything. So let's change that. Let's say I wanted to print hello, exclamation mark, and \n for new line, save this. We have encapsulated the logic, but we're not calling it because the subroutine is not going to be invoked by default. If you want to invoke a subroutine, you can say test, which is our subroutine name, followed by parentheses and then semicolon. Now, if we do this, rerun our script, we're going to see hello. Now, this is all great and all, but what if we wanted to accept some parameters? And let's say that parameter was a name, and we want to say hello, someone. The way how you can pass in arguments is by using a list context between these parentheses where you have defined your function name. So let's say I want to say John, so that's my first argument. But how can we get this argument into our function itself? All the arguments in function is held in this special variable. We haven't seen this before, but basically think of it as just an array. So all the arguments being passed into your subroutine is going to be held into this magical array. Item at index position 0 is going to be John. This array is going to hold this string at position 1. Technically, we should be able to say my name equals, this is just a normal array, but with this special notation. How we can access items on array is we either use the $sign syntax, followed by square brackets, index, position 0. Save this. Oh, we actually want to now interpolate the name. We save this and go back to the console and rerun it. And here we see, hello, John. It might be clearer if we say that this is my args, and I just copy all the values there. There's nothing really special about this array, apart from that it holds the values passed into the function. So here we would be just copying these arguments, and then we could say, instead of this underscore, we're just saying args, right? Because we learned about it before. You access specific elements in your array using $sign notation followed by square brackets. We save this, rerun it. It works as before. And just to quickly show another alternative is that we could have used a shift function, right? We could shift off items from our array, which is this special one, holding all the elements. And when we call shift, we get the first item in the list, and it should be the name. And here we go. Hello, John. This is also where references become very apparently useful, because if we wanted to pass an array or a hash, we wouldn't be able to pass the content as a whole, right? Because what would end up happening is that all the items from array and a hash would be spread into this special array. We wouldn't be able to pass the whole structure. Let me show you an example. So let's say I have my array that holds quote word, just add three strings, which is A, B, and C. Now, how can I get a full structure without simply spreading the array elements into this special function argument placeholder? Let's see what happens first if we just try to pass an array. I'm going to remove this, and I'm going to say, now I want to print the dumper, and I'm going to print all the arguments on this special array. And here I'm passing in array. I save this up, and here we go. So basically, argument 1 was A, argument B was at position 2, and argument C was, at position 3. You might want that, but most likely you didn't. Maybe you just wanted to pass in the whole data structure. And this is where you can use references. So as we looked at before, you can use backslash to get a reference of your array. And now if we debug this special argument placeholder, we're going to see that we passed in, need to save my file, passed in a reference. So we didn't copy all the values into the special array. We actually just said this is a reference in memory to this array. Now what we could do, for example, in our function, we could move the print statement out and say, I want to print out my array, but I want to do something in this function. And let's say I wanted to push something on this array inside the function. And then let's see how our array changes. First of all, I want to get my array ref, which I passed into the function, and I can do this by shifting off the first argument of array. So I'm going to say my arg equals shift special array. So the argument should be the array reference. So I can use push arg. I need to dereference it and say this is a array reference, and I want to say from function. So I'm going to push a new string on this array inside my function after running it. And now I say print, and here we go. Now I have 4 elements on my array, and we push this from function string here when we passed in array reference. Let's quickly look at variable scope. So we know that if we, for example, say my scalar equals hello, and we would try to reuse this my scalar and define a value of something else, it would complain that, hey, it looks like you have another scalar defined with the same name. This does not count when you're using functions, because in functions you are in a different scope. So this curly bracket and this curly bracket indicates that this is scope of the function. For example, let's get rid of this code and just say hello, exclamation mark, and this, and we're gonna call it function, but we have no more array and we don't print anything. If I call this, it looks all good, but if I'm gonna say my scalar equals a, save this, go to the console, print it out, don't complain. My variable scalar masks earlier declaration in same scope. Now, if I move this scalar into here and rerun the function, it's not gonna complain because, well, my scalar is defined inside this function, and the scalar above it is defined into our main file. If I try to use the scalar, you might be wondering if it's going to use the scalar which is defined outside the function, or it's going to use the scalar which is defined inside the function. And let's see. If I run this, and you might have guessed it right. It actually used the scalar inside the function because that's the local scope scalar. And it wouldn't make sense if we had a variable with the same name, which is outside the function, we're redefining it, and we try to print something, and it's re-referencing the value of scalar, which is outside the function. Another thing to note is that you can define multiple subroutines. So I can say test2, and I can say print hello from test2. Now the thing is that you can call subroutines from another subroutine. So let's replace this with hello from test. Save it up. Also to note, the order of how you define subroutines do not matter. For example, if you had a scalar with the value hello and you try to print that before the definition of scalar, that will complain. It's not the case with subroutines. These are actually initialized at compile time, so you can do test, so you call the test subroutine from test2, which is defined before test, and let's replace it with test2, and we run our code, and here we go. We see hello from test and hello from test2, because we are calling test function, which is defined here, inside the test2 function, which is called here. Now, a good thing to note is that I would advise you to always be explicit when you are returning data in your function. It's good to define when you want to return void context through return undef, or you actually want to return some value or calculated value. And Perl functions are always going to return the last value you worked with, so you don't need specifically have a return statement. For example, if I say print dumper, and here I'm going to call the test function. Let's say this function does one thing, which is defines variable a, and it's number 1, and it defines variable b, which is number 2. So it does a plus b and assign it to my c. So if we save this and we run the logic, it's going to say it's undef because we are explicitly returning undef. If we remove this return statement and call the function, it's going to return 3. So sometimes you don't actually want to return the last value which you calculated from your function, but only do the calculations and do some printing or call another function. But the problem is that if you don't explicitly say that, hey, I didn't want to return anything, then it might be confusing for the caller. It's just a good practice to say either you want to return C explicitly as such, or you don't want to return anything, as we did initially by saying undef. Now, as promised, I did say before that we're going to explore subroutine signatures. Subroutine signatures were introduced in Perl version 5.20, and it was classified as experimental until 5.34. However, the experimental warning was removed at 5.36, which is the version currently I'm working with when making this video. If I say Perl version, I'm going to see that this is 5.36. A very good timing to explore subroutines. Now, how you can use subroutines with signatures is by using this program called use feature, and then you import a specific feature you want to use. In this case, you can use quote word notation that we looked at before, and since it's a single name, we can say signatures, and that's it. We should now be able to use signatures in our Perl code. Let's remove this body syntax, and let's return back to the print hello, exclamation mark, semicolon. Let's invoke our function as such. Let's remove the print. And let's say we wanted to print out the name. So how we did it before, we were passing in an argument in list context, which we then got from this special array, which is @_. Now with signatures, we can actually define what arguments are going to receive in this function. So if I say parentheses, and I'm going to say that I want to receive a name. If I run this, it's going to complain. It's going to say too few arguments for subroutine, main package, which is this file, and test. And it says that it got 0 and expected 1. And that's true because we're requesting one argument. And by default, if you use subroutine signatures and you define arguments as such, they are required. And since I'm not passing an argument here, it complains. I can fix that by saying John again, save the file, rerun the script, and it works. It says, hello, John. So what if you didn't want to have mandatory arguments? You can use equals notation and set the value to undefined, which means that the default when not set is going to be undefined. Or you can just say, for example, a string, which is Bob. So if there is no argument provided for this test function, then I want this argument, which is name, to have a value of Bob. If I rerun this, it's going to say, hello, Bob. Now, one thing to note is that if you do want to have an argument which is required, you must have it before the argument which is not required. So let's say name is optional, but last name isn't. So I need to have the last name before the name. Otherwise, you're going to get a warning that says your positioning of arguments is not correct. So I save this and rerun the file. Oh, we added a character that we don't want. So if I rerun the file now, it's going to say too few arguments. Expected at least one argument. So because we expected last name, so we can set the last name to just last. Save this, rerun. Oh, rerun a script, and it's going to say hello, Bob. You can also pass in named arguments, such as using hashes. So I said these are my inputs, and I just want to do one thing, which is print dumper. It's lowercase dumper \inputs. I'm going to print actually the reference of this hash because it gives us a better visual structure to debug what we're passing here. So if I do this, and let's say I have number 1, which is going to hold a value of 1, and number 2, which is going to hold a value of 2. Save this, rerun the script. It's going to say that what we got here in the inputs, named argument inputs, which is hash, which we reference, this is why we get this fine, nice structure, is a key that points to value 1 and key 2, which points to value 2. And this is very nice if you want to use named arguments, because it allows you explicitly say what you want to pass in, such as last name, first name, and so on. Now the last thing I want to show you is something that's called a Slurpee capture. And this is basically an array which captures all the given arguments and you don't need to name them. For example, if I say at inputs, and I want to say that my first actual required input is name, but anything that we pass in afterwards is not deemed required, or we don't want to set default values. So what I can do, I can print out the name what we're going to get, and I can also print out through dumper the inputs we're going to get. So again, we're getting array, right? So we're capturing all in array, but we're going to print out array reference by using this \, just for better formatting. So now, if the first argument is set to, let's say, John, we print it out, it's going to say that, yes, the first item we got is John, but we got no further up elements. And this is because we didn't pass anything extra. Now, if we want to pass more values, 1, 2, 3, maybe let's drop in a hash ref here as well with items A, B, and C. And if I save this, here we go. So the variable 1, argument 1, is John. This is what we're printing out here for this dumper function. And the variable 1 for the second dumper print function holds value 1, 2, 3, and a hash ref, which we passed in here. And this is using square brackets because we are referencing our array inputs. Now this is it for this video. We looked at what are subroutines, how to create and interact with them. We also explore Perl subroutine signatures and various ways how you can define them. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video, we will explore variable scopes. In previous lecture, we saw how we can use subroutines, and we also noticed that if you define my and then the variable, and then my variable inside the subroutine, those names will not clash, because there is a difference between scopes. When you would try to define a variable twice with the same name in the same scope, for example, in this file you're currently looking at, you will get a warning. These differences are called global scope and local scope. We saw the my keyword. I can say my var equals value 1. However, there is another way how you can define your variables, and that is by using OR keyword. So we can say OR variable equals 1. I can print it out by saying print dumper var. Now if I go to console and type Perl script.pl, I'm going to see variable 1. On surface, this might not be visible why it might be useful. So let's explore where this actually does come handy. And that is when we're trying to use a script in another script. We will look into future lectures of how we can use and require files and what is the difference between these two. But for now, let's just create a new file through new file and call it script2.pl. What we can do, we can go back to our script file and let's copy everything. What do you see here? On my Mac, I'm using Command C and I'm going to go into script2, paste that all in. I'm going to print hello from script2. Save it up, go to my script, the original script one, and I'm going to use this special keyword which is called require, and I'm going to require my script2 file. Since my script2 file is currently next to my script.pl, I can use dot notation / which says use the relative path to this folder and script2.pl and end it with semicolon. I'm going to remove these values for now. I'm going to save script.pl. I'm going to go back to the console. I'm going to run the script.pl, which is Perl. Script.pl. What I'm going to see is hello from script2. So that means that when we required this file, the script2, we actually got the print statement invoked. But what if, for example, we had some variables we wanted to use in our script2? Let's say this variable is called my script2 _ var equals secret. So if I save this, and I'm actually going to comment out this hello from script2, go back to script1, and I will try to do print script2 _ var, save this, go to the console. I'm going to say global symbol script2 var requires explicit package name. It hasn't been declared, but it's strange because we are requiring script2 and there is a variable script2 _ var. So why is it complaining? Well, again, it's due to the scope. So by default, if you use my keyword, the scope is currently to this file. This variable is not exposed to the script.pl file. Now, if we wanted to expose this variable to script2, this is where the OR keyword comes into play. We can change my to OR, go back to script.pl, try to rerun. However, as you can see, it's still not working. So another thing we need to do is we need to explicitly define that we want to pull in this variable from script2 file. Otherwise, we're going to get this warning. And this is because of the progmas. You need to be explicitly requiring this variable so there is no confusion whatsoever. And you can do this by saying OR brackets for a list of variables we might want to define. And I'm going to say I want my script2 _ var, save it, go back to the console, try to run the Perl script file again, and it works. What we got here is we said print script2 var, which holds a string called secret, and this is in script2. So we actually could access the variable 2 by explicitly saying we want to use globally scoped variable called script2 var, and we want to pull this into this script and print it out from this file. Now, in last lecture, what we saw was this use feature and subroutines. But we can use another feature, which is called state. And state is a special keyword used before your variables, which tells your script that this variable should be initialized once and only once in the memory throughout the execution of script. What do I mean by that? Well, if we try to introduce a subroutine, let's say test and curly brackets, and let's say I want to say my var, which is a scalar, equals 1, and I'm going to print out var +1 and concatenate it with new line. So if I call this function test, save it, go to the console, I'm going to see 2. A little bit nudge there, so let's maybe add a string before that, concatenate that, and go back to the console. Oh, of course, because now we need to wrap it in brackets to explicitly define that we have a string context, we want to concatenate with a context where we're actually adding numbers, and then concatenate that context with a new line. So you can use parentheses to kind of isolate your context. So if we go to console, try to print it again, we're going to see greater than and 2. And what if we want to recall this function many times? we run it again, you can see 22222. And this is because every single time we're using my in a code block, this variable is initialized each time we call the test function. But what if we didn't want to do that? What if we actually wanted to initialize this variable only once and keep track of this value every time we execute this function? Well, we can use the keyword state. So if I replace my with state, save the file, go to the console and rerun our test functions, which are being called 5 times, and we actually need to change things up. If we think about it, the value didn't change because we are saying variable equals 1 and that was initialized once, but we are adding variable plus 1 and not increasing it. We're just adding 1 to variable and then printing it out. It's not actually setting that variable to higher number. So how we can increase that number is by removing this and saying variable, just concatenate it. And here we want to do var plus equals 1. If we save this, the script, so now we're going to see 2, 3, 4, 5. And just to verify that it actually works as expected, if I change state to my, save it, we run it, it's going to say 222, as I mentioned before. Using my declaration, every time we enter this code block, it sets it to 1, increments it by 1, and then prints it out. Using state, if I change it back, we initialize it once to number 1, and we keep incrementing this variable, which is defined once in the memory. And if I rerun this again, we can see 2, 3, 4, 5, 6. Now, where can this be useful? You might find yourself in scenarios where you're creating maps, lookup maps of some keys, values, which are never going to change in your program, such as translations or special use case mappings. In this case, you don't really want to initialize your map every single time. What I mean by this, you could say state map equals A, 1, B equals 2, and C equals 3. And if I wanted to simply print what's in the map by accessing what was passed into arguments, so we're going to use the $_ remember, because all the arguments are in @_, and to access a single element, we could use $_ and then square brackets, which is the first argument. So if we just wanted to print out the first argument from this map, we can use state because this is never going to change. A is going to be pointing to 1. C is going to always be pointing to 3 in this scenario. And if we remove this and add, let's say, A to print out, yes, looks like we're actually saying that this is a hash using arrayref syntax. So we should be using braces. If I move this into here, set it up, remove the curly brackets and rerun it, forget the semicolon, and this is good. It's always good to read your errors. In this case, I did not add a semicolon. On line 19, it says that there was an error, we couldn't print it, and this is because there was no semicolon added on line 17. And it actually gives you a suggestion where it says syntax error on line 20 near curly bracket, which refers back to previous error, or map wasn't defined. Well, it was defined, but it wasn't defined properly. If we save it, go back to the console, rerun it, we can see number 1. So this is it for this video. We looked at different scopes and how you would apply them in practice. We saw scenarios where you might want to use OR keyword when requiring multiple scripts, or you might consider using state keyword to initialize your data once and only once in memory for execution of your script lifetime. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video, we will explore how we can handle exceptions in Perl. Specifically, we will look into how we can throw exceptions and how to safely capture exceptions. In general, exceptions happen all the time, unfortunately, even in production. For example, if you try to access a database that is not available, or you try to write to a file that does not exist, or read a malformed JSON, so on and so on. If such exceptions happen, we might want to handle them gracefully and recover in the code without breaking the functionality of our script. So let's see how we can handle exceptions in Perl. To throw an exception, you can use this keyword called died. Now, whenever this is invoked, an exception is going to be thrown and our script is not going to execute the code which is followed after the die statement. For example, if I had a print hello, followed by new line, save this, print our script, I'm going to see that our script died at line 7 and nothing was printed out because our print statement followed after die exception and execution of our code did not continue after line 7. If I would move this line before die statement, save this, rerun our script file, it's going to print hello, and then it's going to die at line 8. It's also worth noting that you can throw named exceptions, such as die, cannot, go on. If we save this, rerun our script file, we're going to see hello printed and then cannot go on at line 8. Now this is how you can throw exceptions in Perl. Now the question is how you can handle them. Now to handle exceptions in Perl, you can use this keyword called eval, followed by opening and closing curly brackets and ending with semicolon. If we move this die block inside eval and move this print block after the eval, run our code, we're going to see that our script executed as we expected. So hello was printed to the terminal, and we do not see that the execution of the script stopped. However, what I said before regards to the code not executing after exception is thrown still applies inside eval block. To demonstrate, let's introduce a new variable such as my test and assign world as a value, and then we're going to interpolate this into this print statement by saying hello variable test. Run this. It prints hello world as expected because we defined our variable before eval, and then we print our hello and test variable interpolated. However, if I would try to reassign a value, let's say test equals Bob, save this, go to the terminal, and run our script, is going to say hello world. And why is that? Well, we did declare our variable test, and we assign a string world. Then we try to assign a string Bob to our test variable and print it out again. However, inside our eval block, we also threw an exception, and once this exception was thrown, we never got around assigning the value of Bob to our test variable. Now, how can we know when an exception was thrown? Well, Perl has a special keyword for this. And whenever exception occurs and is being captured in eval block, the value of that exception is going to be assigned in $@ symbol. So currently this variable holds the name of our exception. You can use this variable, for example, to print out if an exception was thrown. So if I move this into our print statement, so semicolon, paste it here, save our script file and run it again, we're going to see the hello world semicolon and then cannot go on at script line 10. Now this can be useful if you want to compare if a value was set in this special variable to know if you want to execute a specific code. For example, if you would comment out die statement, go to the terminal, print it out again, it's going to say hello Bob. So currently our $@ variable holds no exception, so no exception was thrown. We're going to see later on in our lectures how to use logical statements to compare if values are set, and you can execute different type of logic based on if there is or isn't a value in this special variable. Alternatively, if you just want to say that something did not happen according to the plan, but you don't want to stop the execution of your script, you can use a keyword called warn. And this warn is going to print to the standard error output. If I say warn, something is not right, save this, run our script. Oops, and looks like we left the test variable here, so let's remove that. Maybe also let's remove this global variable and just print hello. Rerun our script, we're going to see something is not quite right, which is what we warned about on line 6, but our script actually got around line 8 of printing hello. So warn is something that prints to the standard error output, but it does not stop the execution of your script. And it's very handy if you want to notify when things go wrong, but it's not on a level that it might break your script logic, so you're happy to proceed. To note, this is a basic out-of-the-box approach on how to handle exceptions in Perl. There is a much better way to throw and capture named exceptions that we will look into the future lecture. So this is it for this video. We looked at how we can throw and handle exceptions in Perl's out-of-the-box solution. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video we will explore logical operators in Perl. We already looked at operators used for addition and subtraction of numbers. We also looked into how we can concatenate strings. Now there are many more operators you can use to compare if your numbers are equal or if your strings are equal. or number is greater or less, or maybe they're equal. So let's explore this concept of logical operators. Before we do that, I do want to introduce you to a ternary statement. And a ternary statement is a block which takes an expression followed by a question mark, and then it returns a result, which is at position 1 if it's true, followed by colon, and another expression if it's false. For example, if I want to say print something which is a ternary expression, like 1, which evaluates the truthy, then I want to print yes. Otherwise, if it's not true, we use colon, as mentioned before, and we're going to say no. If I go to the console, say Perl script.pl, it's going to say yes, because this is expression which needs to evaluate to true for us to print yes, and if it wouldn't be true, it would print no. In Perl, all the truthy values are 1 or a string, which is of length at least 1. References are truthy because they're going to point to memory, even anonymous references if you're not assigned to scalars, or a negative number. Now, a falsy value is anything which is, for example, 0, undefined, or empty string. So if I want to say print is undef truthy, rerun the script, it's going to say no, it's not truthy. So same goes for example, if I want to say, is empty string truthy? No, it's not. Now, one gotcha in Perl is that a string which holds a value of 0 is actually a falsy. You would expect that if it's a string, it holds a number which is 0, so technically it's not of a length 0, which I mentioned before, but there is an exception. If you say number 1, this is truthy. And the final falsy value is 0. So if you run this, it's going to say no. Now let's try to do some comparisons with numbers. But before we move forward, I would like to introduce you to a feature which is called say. And say is just a handy function which automatically adds a new line at the end of whatever we're printing. So I can say something, which is the same statement, and I rerun this. Is going to print no to our console, but as you can see, it adds a new line. So it's kind of handier than using print and then manually appending a new line. And especially cases where you're debugging things, you might want to consider just using a say function, which automatically does this appending of new line. So now let's start with comparing numbers. Let's say I want to check if 1 equals to 0. And how you can do that is by using this double equals mark. So it's going to compare if 1 equals 0. And if it is, it's going to print yes. And if it's not, then it's going to print no. So if I try to print this, I'm getting no because, well, 1 is not equal to 0. You can also reverse this and say, is 1 not equal to 0? Which is going to print yes. 1 is not equal to 0. You can also compare if 1 is greater than 0, which should give you yes, if 1 is greater than 0. And the opposite is 1 less than 0, which is going to give you no, 1 is not less than 0. You can also combine less than and greater operators using the less than or greater operator followed by equals. You can see that is 1 less than or equal to 0 if you try to print it out? No. And is 1 greater or equal to 0 is going to say yes, because 1 is greater or equal to 0. The same thing would be if I would say, is 0 greater or equal to 0? Well, 0 is not greater than 0, but it is equal to 0. So this is going to print yes. Now there's also this special operator called three-way comparison, which is basically going to return you -1, 0, or 1, depending on if the values you're comparing are less than, equal, or greater. This is very useful when you want to use it in functions like sorting or mapping things, but probably you wouldn't use it on a daily basis that often. However, let's take a look at this operator. So if I say something, and I'm going to say is 1, then we use this three-way comparison operator, also known as spaceship operator, because it goes like less than, equals, greater than 1. And that's all I want to print. I just want to print the result of this, and I want to comment out the previous line. It's comparing if 1 equals 1, which is 0. So we're getting 0 because value on our left-hand side is equal to the value to the right-hand side. Now, if I set the value on the right-hand side to 0, which is less than 1, and I print this out, give it back to 1. But it's not 1 what we're printing out here. I could change this to 20, print it out, and I'm going to see still 1, because it's a three-way comparison, 1, 0, -1. And now if I change the 0 to 40, which is actually bigger than 20, we're going to get -1. So you're going to get 1 if the value on your left-hand side is larger than the value on your right-hand side, 0 if both values are equal, or -1 if the value on your right-hand side is larger than the value on your left-hand side. Now let's look at strings. Strings are very similar. We have the same comparison logic, which you can say, for example, is A equal or greater to B. However, you need to use these special keywords instead of less than, equals than, or greater than operators. And the equivalent comparison operators for strings are called equal, that checks is A equal to B, and that's a no, because A is not equal to B. Then there's also not equal. Is A not equal to B, which is yes, A is not equal to B. Now the next thing is LT for less than, and it's yes, because A is less than B in alphabetical order. I could swap this around and say is B less than A? Gonna be no, because B follows after A. And there's also greater than, which is GT, and this prints out yes, because is B greater than A, which is yes, because B follows after A, and if I swap this around, I would get no. You also get equivalent operators for less than or equals, so you can use LE for less than or equals. So is B less than or equals to A, which is no, it's neither equal or less than, but if I change A to B, is going to give us yes, because B equals B. And if I change this to C, I'm also going to get yes, because is B less than C? Yes, it is less than, but it's not equals. However, it passed the first condition, so we get yes. And as you have guessed, we also have greater or equal, so you can use GE for greater equals. Now the question is B greater than or equal to C? No. However, is C greater than or equal to C? Which is yes, because C equals C, so we get yes. We can also check this with D. So is D greater than or equal to C? Yes, yes it is, because D comes after C. Now another useful thing you can do in Perl is you can chain your expressions, such as 2 or more expressions has to be true in order to print our positive scenario, which is the yes string, or you can say one or the other scenario has to be true in order to print our positive scenario. Let's look at a simple example. We could say 1 is bigger than 0, and we should use 2 ampersigns. 2 is bigger than 1. If we run this, we're going to see yes printed to a terminal. And this is because our left-hand side expression was true and our right-hand side expression was true. And that means we printed out the yes string. However, if I would change 1 to 3 and try to run the script again, it's going to print no. And this is because our left-hand side still evaluates to true. However, our right-hand side now evaluates to false. And we're indicating with 2 ampersigns that both of these expressions have to be true in order to go into the positive scenario, which is printing out the yes keyword. Now, if you only cared about one or the other expression being true, you can use these 2 pipes, which literally mean or. So now we're saying if the left-hand side condition is true or the right-hand side condition is true, then print out yes. If I run this, it's going to print yes. And what Perl does, it goes in this left-hand side, it evaluates if it's truthy, and if it is truthy, it's not going to even check the next expressions because we know already that our scenario passes, so we can print out the yes string. And you can chain these expressions even further by using brackets, such as I could say if 1 is larger than 0, and I encapsulate these with parentheses. And let's say if 2 is bigger than 3, or 1 is bigger than 0, save this, is going to print yes. If we bisect this, we're going to see that 1 is bigger than 0, and one or the other condition encapsulated after 2 ampersigns is true, which in this case, 2 is not larger than 3. However, 1 is larger than 0, we're going to print yes string. If we would change this to 2 ampersigns, it basically means that all the conditions have to be truthy. If we rerun the script, we're going to see no, because now our second condition doesn't pass, and that means there is no point to evaluate the right-hand side expression because we know our expressions did not pass all the necessary conditions. And you can use this logic even with comparing strings, as we saw before. We looked at less than, equals than, or greater or equals than, and so on. It's not just the numbers. Let's quickly look at assignment operators and some shortcuts. You already know that we can initialize a new variable, let's say a num, that holds a value of 20 using equal sign. And let's try to say this num in our console. If we save it, run it, we get print 20. And now what if we wanted to add a number? We saw that we can add something to a number by saying num equals num plus 5. So we can get 25. But you can use a shortcut. And the shortcut is plus equal 5. And if we run this, we can see 25 again. So basically what this does, it says add 5 to the same variable we're currently working with. So add plus 5 to this num variable. It's just a neat way to do additions instead of writing the full num plus 5 and so on. And as you imagine, you can also use minus equals. We print this one out, we get 15. And we can use all the mathematical operators. For example, if we want to use multiplication, we can use asterisk. If I print this out, we get 100. Or we can use division, and we can get 4, because we are dividing self with 5, which is 4. So we set the num to 4, and so on. We have very similar shortcut to strings as well. So if I say my string for str equals hello, to append something to string, you could say string equals string dot notation space world exclamation mark. So if we say this one out, we're going to see hello world. If we want to quickly append something, we can say dot equals, which is going to give us hello world. Now there's another interesting operator, which is called repetition operator, and it allows you to repeat a string multiple times, and you repeat it by writing x. Very similar to multiplication as you write it on paper, but in Perl, x is to multiply a string. So let's say if we wanted to multiply h 6 times, we can use h character, x for multiplication, 6, and then we print out the string. It's going to print HHH. And if we just add a space to make it more clearer, it's going to print out h space, h space, and so on and so on. We can also use operators to increment or decrement things. For example, my num, which equals 10, and we can say num plus plus and say the num. If we print this out, we can see that num is 11. Or we can decrement num by saying num minus minus equals 9. So it might not seem that it's quite useful at this point, but it does become useful in loops and statements where we calculate things, and we will look into that in our next lecture. Just a final side note is that these are not all the available logical operators in Perl. However, these are definitely the ones you will find yourself using the most. And this is it for this video. We looked at different operators in Perl, how you put them in practice, in strings, numbers, and when you're trying to compare them between each other. I hope you found this video useful, and I'll see you at the next one. In this video, we will explore conditional statements in Perl. So, what is a conditional statement? A conditional statement is a block of code that will be executed if one or more expressions at the beginning of the conditional block evaluates true. Furthermore, conditional statements can be extended with additional cases to execute different logic based on given expressions. This all might sound confusing, but don't worry. Let's look at some basic examples to make it easier to understand. We already explored one of the conditional statements in our previous lectures, and that conditional statement is called ternary statement. This is where you give expression, followed by a question mark, and a block of logic you want to execute if the expression is true. Otherwise, followed by colon, block of logic you want to execute if it's false. Just to repeat it again with an example, we could say, aka print our console, if 2 is larger than 1, then we want to print out hello, otherwise we want to print out world. If we save this, run our code, oops, we need to add semicolon at the end, save this, run our code again, we're going to see hello printed in our console. This is because 2 is larger than 1 and we printed out hello. Now we could execute the opposite case if we would reverse this conditional check, which would evaluate to false. For example, we could say is 1 larger than 1, run our code with perlscript.pl, and we're going to see world printed out to our console. This is because 1 is not larger than 1, 1 is equal to 1. Now this is a basic example. What if we wanted to execute more logic, not just printing out a single string? Well, we could use a conditional statement by saying if or logic bracket where we have to provide expression that evaluates to true, followed by opening and curly braces. And let's add some code there. Let's say I want to print out hello, and I also want to print out rolled. Now let's add an expression in our if statement and say if 2 is larger than 1, save the file, run the code, perlscript.pl, we're going to see two things printed out. We could also do more expressions, such as we could define a variable saying my var equals 1, and then we could print it out by saying my var, then interpolate that variable into a string, save it, run the code again. We're going to see hello, rolled, and my var, which holds a value of 1. You can add a lot of logic and other expressions in the if block that needs to be executed if the condition beginning at the if block evaluates to true. Now what happens, for example, if I say if 1 is larger than 1? Let's save this, run our code. We're going to see nothing printed to our console. This is because 1 is not larger than 1, so this block of code does not execute. We're not seeing anything in the console. In cases where our expression didn't evaluate to true, we could use another keyword called else, followed by opening and curly brackets, and then we could print something like this is else part. Add semicolon, save this, rerun our script. We're going to see this is else part printed in our console. We could actually extend this conditional statements even further. For example, I could say if my variable, which is test, equals 1, and then I could compare if test is larger than 1 and use a keyword, which is else, if written with ELS, if, so you don't write the full else word. Followed again by opening and closing brackets. And let's say if test equals 1 with two equal signs, and add curly brackets. And then we could say something like middle part. Save our code, go to the console, run the script, and we're going to see middle printed out in our terminal. You can add as many as else if blocks as you want. However, do note that if you have else blocks that meet two different conditions that evaluate to true, let's say I have first else if that evaluates to true and a second else if, but if I wanted to print out middle 2, go to the console, run the script, it's just going to print the middle part. So the key point to remember here is that these blocks of code execute in sequential order, and once a truthy condition is met, the execution of your code stops. So this first part did not evaluate to true, but the second part did. Since it evaluated to true, the rest of the code did not run. Now another keyword you could use is unless. And unless works exactly like if, but opposite. So meaning if your condition evaluates to false, then your code is going to be run. For example, if I type unless, opening and closing parentheses, say if test is larger than 2, say this is a negative case, save this, run our script again. And the same as with if blocks, you could extend it further with else if and put your conditions here and end it with else. However, do note that unless can be quite tricky to understand, especially if you want to add multiple conditions. From my experience, you really need to stop and think what this keyword is actually meaning, because it basically says if not true, and if you have many conditions in that unless block, it's just going to get very, very confusing. However, do note that you can use unless in conditional assignments, which becomes extremely useful and much more easier to read than saying if not condition. Let's see what I mean by that. For example, if I want to print out this test variable by saying var test, and let's say I wanted to change the test value to 2 if 2 is larger than 1. If we run this, we're going to see var equals 2 printed to our console, because we define a variable with a value of 1, and then we assign value 2 if this expression is true. We could also say assign a value of 2 unless 3 is larger than 2. If we save this, run the code, we're going to see var equals 1. This is because we're saying our variable equals to 1, and then we're saying assign value of 2 to our variable unless 3 is larger than 2. Well, 3 is not larger than 2, and that means 2 is never assigned to this variable. And this is one of my favorite features in Perl, because you don't need to use ternary expressions to reassign values. If you come from different programming languages, you might know that you have to use ternary expressions such as test equals 2, and then you need to provide your condition such as 3 is larger than 2. If yes, then value equals 2, otherwise value equals 1. If we print this, then we see that the value of 2 was assigned because 3 is larger than 2. In Perl, you can say test equals 3 if 2 is larger than 1. We print this out again. Here we go. This now holds a value of 3. This is it for this video. Hopefully the conditional statements and using conditional statements in assignment context are much clearer now and you feel more comfortable using them in practice. I hope you found this video useful and I'll see you at the next one. Hi there and welcome to this lecture. In this video we will explore loops in Perl. So what is a loop? Well, loop is very similar to the conditional statement principle we looked at before. However, instead of running the code once in a conditional statement, the code in the loop will be executed multiple times, while the expression in the beginning of the loop evaluates to true. Let's look at different loops in Perl and some examples on how to use them. Now the first loop we're going to look at is the while loop. You construct your while loop by typing while, opening and closing parentheses, and then opening and closing curly brackets. As you might have guessed, you put your expression inside the parentheses, as with a conditional statement. Now here you could say something like, while 2 is larger than 1, we want to print hello world. If I run this now, this is actually going to cause infinite loop, because this while condition is always going to pass, meaning it's going to print hello world all the time to the console. Now let's add a condition which is going to tell us when the while loop should stop running. For example, let's introduce a variable as before, test equals 1, and here we could say while test is less than 10, we want to print out hello world. Now let's add the test variable here as well. If I save this, run the script, looks like we're actually causing infinite loop. And the reason is because we are never actually incrementing the test variable, which is causing the while loop to run indefinitely. So what we could do, as we saw before, we could use this post increment with ++. So meaning every single time we're going to hit the while loop, we're going to print hello world and our variable test, and then we're going to increment the test variable by 1. And this is going to run while test is less than 10. If we save this, run our code again, we're going to see hello world and our variable value printed afterwards. So this runs 9 times while the test is less than 10. And you can add different kind of expressions which need to evaluate the true while some sort of condition is not met. And once your condition is met, you can exit the while loop. In this case, we're using a test variable which we're incrementing while it's less than 10. But your case could be different. Now another loop we could use is the for loop. And it's very similar to while loop, meaning we have to give it a condition that needs to evaluate for the loop to run, it knows when to exit. However, the difference is here we provide init variable followed by the expression that needs to evaluate the true for the loop to run, and then we need to provide a handle of how our initial variable should be incremented or decremented for expression to keep running. Let's look at some examples such as say hello, a test variable, and save this. And now let's replace the blocks that we need to initialize in order for loop to run. So we could say my test starting value equals 0. Then the expression could be while test is less than 10. And the handle could be test ++. So we're initializing a test variable to 0. We're running the loop while the test variable is less than 10. And afterwards we're incrementing test variable by 1. We save this. Run our script, we're going to see value of 0 printed up to the 9. And you can of course reverse this by subtracting a value, then checking while the value is less than x, or similar cases. Now another loop in Perl we're going to look at is called for each loop. And for each loop basically goes through every single element in the given list. And once it reaches the last element, is going to stop the execution. For example, we could say for each my item, and then we could provide a list. And very similar to previous cases, we're going to say hello, and we're going to print out item, save this. And another thing we need to do, we need to define the list. So I'm going to say that my list is going to hold values from 1 till 10. And we saw in our previous lectures that what this basically does, these 2 dot symbols, is going to construct a list by populating the items from 1 till 10. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I save this, run our script, I'm going to see an items printed to the console. So what the for each loop did, it went through every single item which we declared in local scope inside the list, and it printed out in the loop. Now, word of warning here, if you're coming from other programming languages, you might expect that when you're iterating through a list and you're modifying item in place, it's going to modify a copy of an item in that list. In Perl, this is not the case. When you're modifying an item in a loop, it's actually going to modify the item in the given list. So what I mean by that is, for example, if we said for each my item, I could say item equals item plus 1, which could also be written as plus equals 1. If we print this out, we're going to see 2, 3, 4, 10, 11, because now every single item is incremented by 1. However, if we exit the for each loop and we print out via dumper or list by referencing it, because it's going to give us a nicer structure. If we rerun the script, forgot to add the semicolon, if we rerun our script again, we're going to see that here we go. We printed out 2, 3, 4, 5, 7, and so on because we incremented an item in the loop. However, afterwards, once we printed our list, all the items on our list actually changed. So in our original list, we had items from 1 till 10. Then we incremented that item by 1 inside the loop, and this changed the items in place in the list we were working with. So just a word of warning, whenever you're working with loops and you're modifying values, just remember that you're modifying the values in the list. Now, another useful thing you can do with the loops, you can nest them. For example, if we introduce a new list, let's call it nested, and we're going to add only 2 items here. It's going to be 1 and 2. And let's go inside our for each loop. Let's remove this addition. And now let's go through our nested loop items. So I'm going to say for each my nested item, the list of nested items, I'm going to print something with \t or tab so that we can better see it in the console. I'm going to say nested, and I'm going to print out the nested item. If I save this, go to the terminal, run the script. Let's remove this dumper so we have a better visibility. Let's rerun our script. What we're going to see now is that we have hello1, and afterwards we have nested printed out, hello2, and nested 1 and 2. So what happens here is that we go through each item in the list, starting with 1, and in every iteration, we're running an inner loop. And that inner loop goes through all the items in this array called nested. So we hit the first item, then we go through 1, 2, that we can see in the terminal here. Then we go to the second item, which is in the main loop, and we go through all the items which are in the inner loop, so on and so on. And you can nest many loops as you want. Just do be careful because the behavior can become quite unpredictable if you have many nested loops. It will become very hard to follow the logic very quickly. You might find yourself in scenarios where you actually want to exit a loop, or you maybe want to skip to the next item. And for this, Perl has some couple of keywords to control your loops. These keywords are next, last, redo, and goto. Let's take a look at the next keyword. So for example, we can introduce something like next if or item equals 2. So if we save this, rerun our script, and if you look at the output, what we're going to see is that we printed out the main loop and the nested loop statements. However, when we went to the second loop item, which holds a value of 2, we did print out the hello item from the main loop. However, we did not print items in a nested loop. And this is because we used a next keyword and a control statement of if, as we saw in previous lectures, that says go to the next iteration if the current item we're iterating has a value of 2. So the execution which followed afterwards never happened. You can also use a keyword such as last. As the name implies, you might figure out that this keyword simply ends the loop by saying that this is the last iteration we want to execute. So if we save this, go to our terminal, let's clear it up, rerun our code, we're going to see that we went through the first item and also through the nested loop. However, once we hit the second item, we printed out the first statement because it's before the last keyword, but we never get around the for each inner loop. And this is because we said that we want this to be the last iteration if the value of the item equals 2. We can also use the keyword redo, and again, as the name implies, it's going to redo the same loop if the item value matches of what we're looking for. If I clear the console, rerun the script with Perl, script.pl. Oh, this is actually going to result in infinite loop. And the infinite loop occurred because we printed out the first item that had a value of 1, then we went to the next item, which has a value of 2, and we say redo this loop if value equals 2. Now, since we're redoing this loop and the value is always 2, this causes infinite loop. Now, what we could do here, we could increment item by 1. Save this, rerun our script, and what we're going to observe here is that we actually printed 1, then we incremented item by +1, and that means it now holds a value of 2. So we redid the loop, however, the value now is 3, meaning this statement executed, it redid the loop, since the value now is 4, we actually never print out the nested loop. So we skip this part by incrementing item by 1, redoing the loop with incremented value, and moving to the next item in the list. Now there's also this keyword goto. For this to be executed, we will need to talk about named loops. And basically what named loops are, you can add this keyword before your loop in uppercase, such as loop 1, followed by colon. and then we can say loop 2. Now what we could do here, instead of printing hello, actually let's leave the printing of hello, but before this printing of the outer loop, let's add the statement that's going to say go to loop 2 if item equals 1. We save this, rerun our code, and let's observe the results. What we're going to see now is that we do have hello2 printed out to the console and the nested loop afterwards. However, in this scenario, which is the first one where the value is 1 in the main loop, we don't have anything printed that says hello1. And this is because we're saying if the item value in the first iteration equals 1, or well, in any iteration for that matter, we want to stop the execution which is in between the goto statement and the loop which you're saying go to, and just execute the next loop. And named loops are quite handy when you're using nested loops. You can apply these names for keywords as next or last if you want to be specific which exactly loop you're referring to. So what I mean by that is if we remove this part, let's leave the say hello item which is in our main loop, and let's go to the inner loop. And after printing nested, I'm going to say last loop 1 if item equals 1. We save this, rerun our code, we're going to see hello1 printed, then nested1 printed, and that's it. And this is because, again, we went through the main loop, we printed item 1 here, then we go into second loop, we print the first item in the nested loop, but then we say last loop, which is named 1 and refers to the outer loop, if the item value is 1. Since the first item in the list has a value 1, then that's it, we're done with the execution. So named loops are quite handy if you want a granular control of the loop execution when you have nested loops. This is it for this video. We looked at loops in Perl and how you can apply them in practice. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video we will explore what are regular expressions, also known as regexes, and how to use them in Perl. In a nutshell, a regular expression is a string of characters and symbols that defines a pattern you want to match against your string value. You might have heard that Perl is very powerful when it comes to using regular expressions, and that is quite true. It is extremely easy to use regexes in Perl, and there are various tools baked into Perl to match and modify your data using regular expressions. Let's look at some examples of using regexes in Perl. We'll be using conditional statement to see if our regex is true. So we can do if something is true, then let's say, aka print something to the console, which is going to be matches with exclamation mark. Now how you can match a regex by giving a variable such as test, then equal sign, followed by tilde, and 2 forward-leaning slashes. And then you could add your character matching such as dog. If I would define my variable and say test equals cat, let's also introduce else expression, and let's say does not match, save this, run our script, we're going to see that this does not match. And it makes sense because we're testing if this variable called test matches a pattern which is dog. Now, if we try to match something like dog, rerun our script, we're going to see, yes, it matches. And you can add other strings such as cat and mouse, and in between there we can have dog. And it's going to say matches, because the regex looks at all of the string and it looks for this particular pattern of dog inside that string. Since our string contains cat, dog, mouse, and it has dog between, it matches. So it prints out matches. Now, what if you actually wanted to test for something like, is there a forward-leaning slash inside the regex? And if we run our Perl script now, it's going to say, oof, there's a syntax error. And that makes sense because our regex pattern is defined by 2 forward-leaning slashes. So by adding the third slash, it's invalid syntax. So one of the alternatives is to use backslash. And backslash is basically escaping these special characters, and they're going to be understood literal characters. So here we're looking for literal forward-leaning slash in our string. If we rerun this again, this does not match because our string does not have a forward-leaning slash, but if we add that here after dog, save this and run our script again, it matches. An alternative is you can use this M modifier, and what M modifier allows you to do is change the wrapping syntax of your pattern. So we can use something like curly brackets instead of forward-leaning slashes to build our pattern. If we rerun this again, it says it matches. Now without the M modifier, this becomes invalid syntax, and it's already seen by the syntax highlighter, by the code editor. If we rerun, it basically says something is not right with your code. You can also add some modifiers. So first, if we fix this and dog and forward-leaning slash, we rerun this is fine. So you could actually try to match something at the beginning of the string and the end of the string by using this roof character and then $sign. So this means that your string, the pattern you're looking for, has to be exactly dog / from the beginning and the end of the string. So now if we rerun this, we're going to see does not match because there's a cat and a mouse wrapping our pattern we're looking for. Now if we remove the cat part and we remove the mouse part, save this, rerun our script, we're going to see that it matches. You can also use special regex keywords, such as to look for a character or look for a number or something that is not a character or not a number. And you can do this by saying backwards leaning / and for any word character, you could say W, and here if we amend the string to say dogs, rerun our script, we're going to see that it matches, because now we're looking for anything that is dog followed by a character. So this extra character is S. Now to match something that is not a character, you can use capital W. And I'm going to add a resource link which is going to tell you what exactly is considered and is not considered a word character. Let's add a hyphen character and rerun our script. We're going to see that this matches because hyphen is not considered a word character. You could also use \d, and \d is a number. Let's say if you're matching against dog1, save this, run the script, it's going to say matches because we're looking at something that is beginning to the end containing dog followed by number. So since 1 is a number, then this matches. So what if we added another number, save this, rerun our script, it's going to say it does not match. Because here we are looking for exactly one number after the string dog. So we could do something like plus. So that means we're looking for one or more number after the dog. We can add more numbers, save this, rerun our script, and it's going to say matches. We could also use star instead of plus. If we run this, is going to say matches. Now what star does, it basically says there can or cannot be a number and we don't really care. So we can match against dog exactly, or there could be numbers such as these. And if we save this, rerun, it matches in both scenarios. Now what if we want to say I want a dog and 2 numbers followed after dog keyword? Well, we could use these opening and closing curly brackets and we can say 2. So this means we're looking for dog string and followed by number exactly 2 times. If you rerun the script now, you're going to say does not match. If you reduce these 2 numbers, save our script file, rerun the code, it's going to say matches because there are 2 characters which are numbers after dog keyword. You can also extend this by saying 2, 4. And this means we are looking for 1 to 4 numbers after the dog keyword. So you can do 1, 2, save this, it's going to say matches. And now if we add 9 at the end, we're going to say does not match because here we have 1, 2, 3, 4, 5 number characters. If you remove this, we run our script, we're going to see that this matches. If I would add many space characters, save the script file, run the script again, it's going to say matches. We could inverse this and say anything that is not a space. So if you run this, it's going to say does not match. And if you would replace this with dogs again, rerun the script, it's going to say matches because we're looking for dog followed by anything that's not a space. Or we could also look for strings where we don't care about if they're uppercase or lowercase. And in order to do that, we could use this I modifier. So let me just quickly remove that and change this to dog. Remove this not space character. If I save this, if I run the script file, it's going to say does not match. Now this is because we're looking for lowercase dog, and in this variable we have capital dog string. So if we add this I for case insensitive, rerun the script, it's going to say match. And we can have lowercase, uppercase mixed in here. So let's say uppercase D, lowercase o, and also lowercase g. If you rerun this, it's going to say matches and ignore if the characters are uppercase or lowercase. You can also inverse this matching, meaning we want to check if something does not match your pattern, then we want to enter the truthly block. For example, if we said this variable contains a cat, and instead of matching it against dog, we want to say if this does not match dog, then we want to execute the logic with print matches. So if we save the script, run it, it's going to say matches. Now if we add our pattern as cat, save the script file, rerun it, it's going to say it does not match because test holds a string of cat and it does not match a cat because it actually matches a cat, meaning it's going to print that does not match. Now another very useful thing what we can use are captures. And captures allow you to capture patterns in the string. If you look at the previous example where we added some numbers but we didn't care what number this is, and let's say in our logic we wanted to actually capture what numbers followed our string and print them out. Well, we can do something like test, compare if this equals our pattern, which is cat, add the \d for number, plus for numbers being one or more times, and then we can use parentheses. Capture pattern we're looking for. Now the patterns that are being captured are going to get stored in these special variables, which are $1, $2, $3, so on and so on. So what we could do here is that if our test matches this pattern followed by one or more number characters, we want to print out matches followed by $1, because this is our only capture in the string. If we save this, rerun our code, we're going to see matches followed by 1, 2, 3, and this is what we're printing out in our first capture. We could also capture more parts, such as we're looking for numbers and then let's say space characters. So we're going to have cat 1, 2, 3, then let's add a bunch of spaces, and then we're going to add how many spaces we captured in the second capture group. If we print this out, we're going to see matches 1, 2, 3, and here's our space. Now you can use these regular expressions in loops, conditional statements, to capture part of the strings, process strings, and do lots of cool things with it. Let's look at an example where we're processing a list of items, and we want to capture first 2 characters of each string we're processing. So I'm going to remove this part of the code, and I'm going to introduce a new list, which is going to hold 3 items: dog, rat, and cat. Now here I'm going to use for each loop. And we know that for each loop goes through every item in a list and processes into a code block. So I can say my item, and I'm going to go through each item in the list I defined above. And for each item, I'm going to match it against 2 word characters at the beginning of the string. So precisely 2 characters. So using captures, so 2 parentheses, and I'm going to say my capture. So if we run this code, we're going to see DO, RA, and CA. So again, we define a list with 3 strings, dog, rat, cat. We go for each item in that list. We're comparing that item with this pattern, which says any word character exactly 2 times at the beginning of our value. And then we're printing out the pattern we captured, which in this case ends up being DO, RA, and CA. Now, another very useful thing you can use with regexes are replacements. Replacements basically allows you to give a pattern you want to match against and replace that pattern in the given string value with something else. So let's build up on our given example. So I'm going to remove this M modifier and replace this with S, which indicates that this is a replacement. And I'm going to introduce another forward-leaning slash, which now here holds the pattern we want to replace or match against. And what I want to do, I want to go through all the items in the list and I want to replace them with the keyword replaced. So I type in replaced, and here we're not going to capture anymore. So let's remove these parentheses. Let's also remove the anchor tag. And instead of saying the capture, because we are not capturing anything anymore, so this is going to be undefined, we're going to say item. We save this, rerun our script, we're going to see replaced followed by GTT. So it means we went to every single item in this list, we looked for anything at the beginning of the string, which is 2 word characters, and we replaced it with a literal, which is replaced. And then we printed out the modified item, which resulted in these 3 strings: replaced G, replaced T, and replaced T again, because G, T, and T. Now before we move on, I just quickly wanted to come back to the captures and show you how you can store every single matches against your pattern into a list of items. For example, if we wanted to compare our item to a pattern and capture specific parts of it in a list and store it somewhere, what we could do, we could assign all of the captures to a list context, because every single time a pattern is matched, the regex is going to return all the matches against your given pattern. Let's see that in a practice. So if I say my at captures, now I want to go back to using M keywords, and instead of replacement, I'm just going to use a simple match. So here I want to capture the first character, and let's say I also want to capture the second character. So if we replace item with dumper / at captures, which is going to turn this into a reference, and it's going to be nicely printed in the console. We run this. Oops, actually we need to compare this against something, because now we're saying all captures is being compared against this pattern. But what we want to do, we want to assign all the captures of item to our array. We rerun this. We're going to see that every single time we went through the loop, we compared for strings and we captured first two characters. So the first capture was stored as an item 1 in the list, and the second capture was stored as an item 2 in the list. That goes on for all the strings in our defined array, which is called list. So what we got captured here is DO for dog, A for rat, and CA for cat. So this is it for this video. We looked at how to use regular expressions in Perl, how to capture and replace parts of strings, how to match on patterns, and a handful of special characters to help with string matching. Do note that what we looked at in this video is only the tip of an iceberg when it comes to regular expressions. There is so much more to cover and learn. It simply would be impossible to add everything in one video. And even with these basics we covered, this video was quite long. I do hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video we will look at some very useful built-in Perl functions that you will most definitely be using quite often when writing Perl code. Some of these functions, such as delete, keys, values, push, shift, unshift, pop, scalar, and others, we already saw in previous lectures, so I won't go into details on them. However, and rest assured, there are plenty others worth mentioning, some of the popular ones being, for example, map. So what map does, it basically executes a code block for every item you give it. For example, we could introduce a new array, which is called list. And what it's going to do, it's actually going to produce a new list with modified items. Now, if we say that my list is going to contain the cat, dog, save this, and we use a function such as uppercase for UC, we can provide the current item context in the map. And the current context, as we saw before, is defined by $_. So if we save this, run our script, so Perl script.pl, nothing happens because of course we need to also print our list, which is the new list. So say dumper, and then let's reference this for easier readability and give it a new list. Rerun the script. Oops, we also need to add a semicolon. Run this again, we're going to see cat and dog. So our original list contained lowercase cat, dog. We gave our map function a block of code which says uppercase every element you give to this map function, which is the list, for two strings, and produce a new list, which now contains uppercase cat and dog. Now do take note that opposite to using for loops, if we use map function, it's actually not going to modify the items in place. If I print out the list, the original list we provided to map function, I'm going to see that it still contains lowercase cat and dog. So it actually copies every item and returns a new list. In this case, we are assigning the list of items to a new array called new list. Of course, we could also modify this further by saying my item, which is a local item, uppercasing the current context, assigning it to this variable. And then let's say we want to append something to the item, such as _new, and then we want to return the item. We're going to see, oops, actually we need to print out the new list because we're printing out the original list, which as you can see still hasn't changed. And we're going to see cat, the uppercase version of our initial string, which we then use to append a string with _new, and then we're returning that item. Now another useful function we can use is called grep. So grep is kind of similar to map, but not really. What it does, it takes list as well, similar to map. However, instead of modifying the item in place, it's going to compare something, and if it evaluates to true, it's going to return that item to a new list. So let's see this by example. So if I replace map with grep, remove all of this code logic, and let's say I wanted to return the item if it equals to cat. So I could use the current context, $_ equals to cat. And basically what you provide to grep is an expression which, when it evaluates to true, is going to return that item in a given list. If it's going to evaluate to false, it's just going to drop it. So if we save this, rerun our script, we're going to see cat entered in our new list. This is because we went through all the items in the list, compared if this equals to cat, and if it does, we're returning it from the grep function and it builds a new list. We can also say if this equals to cat, this being the current context, or the current context equals to dog, we want to return it. We print this again, now we see cat and dog in our new list, because the first element matched from this condition, and then the second element matched from the right-hand side condition. Now another useful function you can use is called split. And what split does, it basically takes a pattern and a string, and it splits that given string based on that pattern, and returns multiple parts the string was split into. So let's look at example. If I say my parts equals split keyword. And we're going to give it a pattern, which is going to be, let's say, letter E, and we're going to give it a string, which is test. Let's also extend it with another test for this to become clearer. We save this and rerun our script. Oops, of course we also want to print this out, so if we say dumper and parts, save this, run the code, we're going to see these parts, which is t, st underscore t, and st. So why is that? Well, this is because we're saying our pattern we want to split on is the e, but we don't want to preserve the e, we just want to split on it. So basically our string becomes t, part 1, then the part 2 is st followed by t up until the second e, then the last part, which is st. So our string got split into 3 parts by the given pattern letter e. Now you can also do cool things such as, for example, if you give no pattern whatsoever, what's going to happen is that your string is actually going to get split on every single character. And sometimes this can be quite useful if you want to reverse strings, modify them in a particular way, or any other scenario. But it's just good to know, if you don't give it a pattern with the split function, it's just going to split on every single letter in that string. Now the next function we're going to look at is called join. And join is opposite to the split. So instead of splitting a string into multiple patterns, it's going to actually join a list of strings into a single string. So let's say that we want to redefine our parts, which is going to be both words A, B, C, D, E. We save this, and instead of the parts, we're going to say full string equals, or join keyword, followed by a string what we want to join on, so let's say underscore, and followed by the list. So if we replace parts with full string, and we run our code, oops, actually it's not called list anymore, it's called parts. So this again, we run the code, is going to be ABCDE, joined with underscore. Of course, you can just apply empty string and rerun this again, and that's just going to be ABCD joined all together. Now, some other useful functions are UC for uppercase that we saw before, but we can also use LC for lowercase. And we can uppercase first characters or lowercase first character. Let's see an example. So if I can have my test equals cat, and I want to say that my cat equals, you see, uppercase test, replace full string with a test variable, save this, run the code, is going to be uppercase cat, and we already saw this before, this is nothing new to us. However, we can also uppercase the cat, and we can use LC for lowercase. Now if we print this out again, instead of printing out uppercase cat, is going to print lowercase version of the cat, because we're running through this LC function. Now we can also use LC first. If we rerun this, we're going to see that it's lowercasing the first character. Everything else is still uppercase. Now if we reverse this and we have a string which is cat, and we say UC first, oops, UC first, rerun our script, and as you might have guessed it, instead of the first character being lowercase, it's actually going to be the first character uppercase. Now what if we wanted to find the length of a string? Well, we can use the keyword called length. So if I assign this to my size and remove this part, and if we print out size, we're going to see 3. So what the length does, it counts the characters in your string. So our string consists of 3 characters, CAT, so it prints out 3. If we say cats and dogs, save this, rerun the code, it's going to be 11 characters. Now we can also use a function such as rand, which is going to give us a random number from the given number to the function. For example, if I say rand and give it a number of 10, if I save this, rerun the code, oops, looks like we're still printing size, but we want to print the test variable. If I rerun the code, it's going to give a decimal number. And this is where another function could actually become handy. So if you wanted to convert a number without decimal places to an integer, you can use a function called int. We wrap our random function given 10 with int function and rerun our code, we're going to get 6. So thing to note is that, for example, if I give it a number such as 4.5, it's going to give us 4. If I would give a number such as 4.6, it's still going to give us 4, because what int does, it doesn't give the floor, meaning the lowercase version after decimal points, or the uppercase. It just removes the second part of a decimal number. So even if you have something like 4.99999, if you save this, rerun it, it's still going to be 4. Some more interesting functions is you can use keywords such as sleep. So sleep is going to stop the execution of your code for the given amount of seconds. So if I say sleep 2 for 2 seconds, and then I want to print something like I woke up, and save this and run our code, we run it, nothing happens, and boom, we got I woke up printed to our console. So sleep stops the execution of our code for the given amount of seconds. Now going back to strings, we can also get substrings of the given value. For example, if I say my value equals substring with sub str, and then I give a string such as cat and value 0 and 1, save this, and then we say the value, save the code, run it. It's going to give a letter C, you can see here. So what this does, the substring basically takes a string, it takes the index of that string and how many characters at that index you want to capture afterwards. So if I said 1 as the middle number and 2 as the last number and run the script again, is going to print out at. And this is because we're looking at index 1, which is A, and then after that specified index is going to take 2 characters, which is AT, and that is exactly what we're seeing printed out in the console. Now you might also be interested in epoch time, and to retrieve that value you could, let's say time. So we're basically calling say function a value of time function. We run this, you're going to see the seconds elapsed in epoch time. We rerun this, we see this was 7 seconds ago, and so on. So this is it for this video. We looked at some of the more popular functions used in Perl. This list is nowhere near complete. Make sure to check the lecture notes with reference to resources where you can find more information on the functions we looked at and plenty others. I hope you found this video useful, and I will see you at the next one. Hi there, and welcome to this lecture. In this video we will look at some of the special reserved Perl variables and how you can use them. We already used some of these variables before, such as regular expression capture placeholders using the $1, $2, etc., and the current context variable written as $_. However, there are many more to explore. So let's look at some other variables. Now one of these variables is called argv for argument values. And as you can see, this is array. And what this value is going to hold are the current arguments passed to your script through command line. So let's print it out now as it is by referencing the argument values. And if we run our script, we're going to see that this is an empty list. Now, if we rerun our script with variables such as 1, a, b, or 2, we're going to see that our list, which is the argument values, now holds 1, a, b, and 2. That are the arguments in the exact order we pass to the script. And you can use the argval exactly as you would use the list. So if you wanted to access the first item in the list, you would use $argv and access the first value in the list. So what we can see now printed in the console is 1, because this is a list, we're accessing the first element and it holds a value of 1. Now another useful thing you might find is using these two $signs, and what it holds is the actual process ID of the script. So every single time you run a process on your system, it gets assigned a process ID. If you're doing some sysadmin tasks, or you want to see if your script is running, you can always check the process ID. Now, how we can know that this process ID is actually true, what was printed? Let's introduce a infinite loop. So if I say while 1, do nothing. If I run the script, it's going to print the number 9077, which is the current process ID. And if I open up a new terminal, I could check the current running processes. And how to do that, you can type ps aux and you can grep for specific pattern, which in this case would be our script name, script.pl. And we're going to see that our script is currently running with process ID 9077. This is the exact ID we got printed out in the previous terminal window. And we see actually 2 entries here, and this is because the second entry was our grep statement. The first process is the one where we actually have the infinite loop running. I have gone back to my first terminal and I have quit the script that I ran in infinite loop before. So we're basically back in the previous state where we were. Now the next variable we're going to look at $sign closing square bracket. We'll remove this infinite loop, and if we rerun the script, we're going to see this number, 5.036000. And you might be wondering what it is, and this is actually the Perl version that is executing this script. So if I say Perl version, to see which version we're currently using, is going to be 5.36.0. So it might be useful in some scenarios. Let's explore this array called inc, or includes. So if I print this out in the terminal, I'm going to see a couple of things currently in this array. And what this inc that stands for includes holds is the actual paths to modules and current Perl version core modules that we can use in our code. And this can become extremely useful, and we're going to see some scenarios in future where we can modify this includes array. For example, if we have modules in a different directory, we can push new paths to this include array, and Perl is going to find them. But for now, just know that it holds absolute paths of directories where Perl can find modules. Now the next variable we're going to look at is called env. And this is not a list, this is actually a hash. So it's written as capital ENV, and it stands for environment variables. If you run our script, we're going to see our default system variable, such as what is the home directory, it is right here, and the current language, and so on and so on. And this is quite useful if you want to run your script with specific environment variables, such as you could do test env var equals 1, and instead of printing just all the environment variables, we could just print this one item in the hash, which is going to be the test env var. Save this, run our script, we're going to see that var equals to 1. Maybe let's just add something more useful. For example, custom string. Save this, and here we see that this environment variable was picked up by the script. The next variable we're going to look at is this standard input. So the standard input is basically just taking the input from your script. And we did see it briefly when we were looking at how to run Perl through command line. So if we repeat this through while loop, and we use this diamond operator, and we explicitly say that we want to take the standard input, and what we're going to do, we're just going to print out the current context, which is again accessed by $_. If we save this, run our script, maybe let's run it without the environment variable. So let's run it again, and let's say we want to do hello, and here we go. So we wrote hello, and then we just got the standard input and we printed out hello again. And as you saw before, we can do modifications on this input, such as uppercasing it, lowercasing it, splitting it up in characters, so on and so on. So let's quit this for now, and let's check the next variable, which is called __ file and 2 following underscores. If we save this, run our code, it's going to print out script. So what the file holds is the name of our script file, which in this case is script.pl. We can also use something like __ line, 2 underscores again, on this, and we're going to see 10 because we're currently on a line 10, and another one called package. If we save this, run our script, and it's going to give us the main package. Not very useful for now, but just know that the main package is the current script you're working in. When we're going to be looking at modules, this is going to become much more useful because then this variable references our actual package name. Since we don't have any package, no Perl module, it references our script, which is the current main package. So this is it for this video. We looked at some of the Perl special variables and how you can use them in your scripts. As with built-in functions, this list is nowhere complete. My suggestion is, don't try to memorize all of these special variables. Most likely you will only use a very small subset of them anyway. You can always refer to the documentation to find what you're looking for. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. It's time to bring out the big guns and talk about object-oriented programming in Perl. In this video, we will explore what are classes, objects, attributes, and methods, and how you approach object-oriented programming in Perl. To note, we will be exploring the built-in Perl's object-oriented system out of the box in this video. However, later in this course, we will use a module called mouse to create and interact with objects. The mouse module will allow us to build much better object-oriented code where we can introduce attribute types, validations, and other great features that are not provided by Perl's default object-oriented programming approach. Let's get started. First of all, what is object-oriented programming? Well, it's a concept that is based on structuring your data and logic in objects. Each object has properties and methods defined by their classes, but the attribute values and results produced by these methods are specific to each object. For example, you can define a dog class, and we know that dogs have specific breed, height, weight, color, name, and other similar properties. You can view these as attributes of a dog class. You can create an object of a dog class and set attributes such as breed equals Labrador, height equals 60 centimeters, weight 50 kilograms, color golden, name Fido, so on and so on. This specific dog, Fido, now would become an object of a class dog. You can add methods to your class such as getAverageSpeed, where you calculate the running speed of Fido using height and weight. It might be a silly method to have, but hopefully it explains of how each method would produce different results for each object of the dog class. If all of this sounds confusing, no worries. It's a tricky concept to grasp at first, but it becomes so much easier the more you practice object-oriented programming. Now, let's look at an example what we discussed being used in Perl. Now let's start by creating a new file, and we're gonna call it dog, as we discussed before. Instead of using PL extension for Perl scripts, we're gonna use .pm. For Perl module. We're going to write the package name, which is dog. So technically, module files are not meant to be executable, so we don't need to provide our system with indication of how this file should be run, because you don't really execute the module files directly. And as with scripts, it's good to return a truthy value. And it's especially required for modules because you need to tell the use directive, as we saw before, and also this required directive, which we're going to look in next lectures, the compilation of this class succeeded. And if you don't have this truthy value in Perl module files, your compiler is going to complain. Now, the next thing we're going to use is strict pragmas and use warning pragmas because we still want to write better and less error-prone code. Now, afterwards, what we're going to do, we're going to introduce a method which is called new. Now this method is going to receive the first argument as a class, and this first argument is going to refer to the current package name. So before, the package names were not that useful when we were working with script files, but now, since we're working with modules, this is going to become much more useful and in that matter necessary because we will want to initialize instances of these classes with this package name. Now let's add some attributes we talked about before. For example, breed, height, weight, color, and name. And we're going to get all of this from this argument variable we looked at before. So basically this is an array that is going to hold all of these arguments passed to the new function. And the class package name, which is basically dog in this case, is going to be automatically given by the Perl module file. So let's remove that. And the next thing you want to do, you want to initialize self. And self is just going to be a hashref that is going to hold a couple of key value pairs. And these key value pairs are going to be attributes that we're passing to our class at the time when we want to initialize a new object. So for example, we want to set the breed to be the breed, height to be height, weight to be weight, color to be color, and name to hold a value of name that we are going to be passing to this instance of class dog. Now the next thing we want to do, we want to bless our instance with this keyword bless by providing self, which is the hashref, and the class, which is the class name, being dog. Now basically bless is going to do some inner magic, but you can look at this as that objects in Perl are glorified hashrefs that have a name assigned to it, class name, that says that this hashref belongs to this class, which in this case is going to be dog. And afterwards we want to return self. Now we're done with constructing and setting the attributes of this class. Let's see how we can use this new package we just created. Let's go back to our script file and let's try to use it with the same use statement we did for data dumper. Let's try to pull in the dog class. So if we save this, and now if we try to run our script, it's going to complain. It's going to say that, looks like I can't find this dog PM in includes. And we looked at this include global variable before. This is where this global attribute becomes useful, because now you can specify additional paths where Perl can find this module. So for example, and we didn't look at this keyword before, we're going to use begin. And begin block is basically just telling that this execution of code has to be done before these use statements. And again, we're going to look into how use actually works behind the scenes, but just know that when you are saying use a module, it's actually running begin block as well and putting it at the start of your script. So if we try to push something on includes array now, this would actually get done after we're requiring our modules. So with begin block, we're saying that we want this logic where we're adding new paths to the includes to be done before we're requiring this dog module. So I could do something like push at inc, which is the includes, and here we can provide the absolute path of the directory where this module can be found. And we can try to discover the current absolute path using our current working directory or modules, but I'm just going to give it an absolute path of the folder we're currently working from. So if I push this to the includes, save the file, run it again, it's not going to complain, because now Perl knows from the includes variable where we can find this dog. Now if I would remove this begin block and just try to push something on the inc, it's going to complain. And this is what I talked about before, because use statements are just using begin blocks behind the scenes. So requiring of this module actually gets executed before we're pushing onto this includes array. Now that's one way how to use a module. An alternative is to specify additional libraries where you can find modules through command line. In this case, we could say Perl -i for includes and dot for the current directory. Now if we run this, the script is not going to complain. And if I remove the includes path, it's going to complain again. And I'm going to go with the latter approach because it's just easier and we don't need to add extra boilerplate. Now we know how to create classes and set the expected attributes. And we also looked at how we can provide paths to tell Perl where to find our modules. Now let's look at how we can get an instance of this class. Now to get an instance of this class, we can say my $, and dog. And this is just going to be scalar that is going to hold a reference of the dog instance. And to initialize a new dog instance, we can say dog or package name and new. And this is this method we created in our package file, aka class file. And we can see that it accepts a couple of attributes. So I'm going to just copy them over, paste them here, so we keep the correct order, and set them by providing these arguments in the new method. So I'm going to say that the breed is Labrador, the height is 50, let's say weight is 70, we're going to have a chunky Labrador. Color, I'm going to say that it's golden, and for name, I'm going to say Fido, and save this. If you run our code, all looks good. There's no complaints, but nothing happens. And nothing happens because we're not really calling any methods or we're not accessing the attributes. So let's change that. Now Perl's object-oriented approach out of the box doesn't really come with accessors, getters, and setters. And the getters are pretty much saying, give me the value of an attribute on this instance. And setter would do the opposite. It would say, set a new attribute value for this instance. So let's add some getters first. And getters are nothing more than just subroutines, aka functions. So we could do sub, let's call it a breed, with a function declaration. I'm going to say my self equals shift. So we haven't seen shift working on nothing before. But basically, when you're working on Perl, you're always getting the current context when you're calling a method. So in this case, we could also write shift, the current argument list. But in practice, you're going to see that usually it's just the shift keyword. Now self is something new. It's not the class anymore. Self is actually going to be the blessed version of the class, aka is going to be a hashref that holds key value pairs of these values. So what we could do, we could return self an access key called breed. Now if we go back to our script file, and here we print something like dog, breed, save this, run our file, is going to say Labrador. You might be wondering, but hey, can I not access it simply as a key on my dog instance, such as breed? And if we run this, yes, yes, you actually can. But that's not a good practice because you're actually accessing internals of that instance. The proper way how you work with attributes, setting and getting them is through the setter and getter methods, which we just have introduced here. Because the attribute names can also change, or you want to add new logic later on, and it's good to encapsulate your getters and setters in case you want to extend the logic or the attribute name changes, so you don't have to go in every single place in your code and change the value of that key, which is the current cell blessed reference. Now let's quickly add another attribute, getter. For example, height, and I'm just going to return height here. If we save this, go back to script, and we're going to say height just to see that it's working as expected, and it does. It prints out 50 to the console. Now, what about setters? Well, there's really nothing magical to it. They're the same as the getters. They are functions where you are modifying the currently blessed self-reference by overwriting the value. So you could say something like sub set height, and here we could expect to receive two attributes, so self and the new height. And we're going to get that from the argument list. And what we're going to do, we're going to access self height. I'm going to set it to height. And you might be wondering, well, didn't you just say it's not good to access internals by using keys on these hashrefs, which are blessed selves? Yes, it's a bad practice to do that, but as long as you're doing it outside of the actual class. So here we're defining these methods and attributes inside the class, and we're modifying them on the instance. So as long as we are not doing it outside of our class, this is perfectly fine. So now if I go back to the script file, and before I'm printing out the height, I'm going to say dog height equals 70. So now that we originally set it to 50, maybe I'm going to choose a different number because we're using 70 for weight. I'm going to say 120 and save this, run the code, and we're still getting 50, and that's because we are actually calling the getter method, so we want to set the height. If we rerun this, we're going to see 120. Now, what about methods? Well, again, it's nothing really magical about them. You just introduce a new subroutine, aka function. So we can add something like sub, get, height, and weight. And again, we're going to get self as the first argument. We're going to shift it off from the argument list. And what we're going to return is going to be self, height, plus self, weight. We save that. Go back to script, and let's remove the setting of a height, and let's just do this function name, which is get height and get weight. So if I call this, which is set height and weight, apologies, it's not set, but it's actually get, save this, run the script, is going to return 120, because 50 for the height and 70 for the weight equals 120. I could change the height to 100, save this again, rerun the script, and it's going to be 170. Now, another useful thing you can use in your classes is this default method called destroy, and you write it with capital letters, destroy. And here we're just going to print something out like print by everyone, exclamation mark, new line, and save this. If we rerun our script, it's going to print out 170 from this method, and then it's going to say by everyone. And the destroy method is basically useful for if you want to do any cleaning up in your instances before they get picked up by the garbage collector. For example, if you wanted to do some logging or reach out to a server or anything whatsoever based on different use cases, you can do that in destroy method. So object-oriented programming is quite useful because you can initialize different instances of a class. So if I have dog2, and I'm going to say that this is poodle, height is 10, weight is 10, or maybe 20. For color, something else that doesn't say just color, so white, and the name Bob, poodle called Bob. We're going to have a different isolated logic per instance of a class. So now, if I say dog2, which is going to get the height plus weight, and I'm actually going to concatenate it with dog, and I'm going to be cheeky here, and I'm just going to access the key on the instance, which is the name, because we didn't introduce the setter method, but don't do that. A bit of spacing, concatenate this, and the same for dog2, and let's change that to dog2 because that's our variable name. Save this, run the code. We're going to see two separate calculations. So for Fido, which is the first print statement, we get 170, so these values summed up, and for dog2, which is named Bob, we're going to get value 30. Which is these two values summed up. And you're also going to notice that destroy methods run individually for each of these instances. Just to quickly mention, you could also be passing in named arguments as we looked at the functions where we were using subroutine signatures, or you can pass in hash or a hashref instead of arguments in a list. It's really your choice. So this is it for this video. In this lecture, we looked at what is object-oriented programming and how we can create objects using Perl's default out-of-the-box object-oriented system. Note that we did not touch on inheritance and using roles to compose our classes, in case you have heard of these terms. These are a bit more advanced concepts that we will be looking in the future lessons when building classes with Mouse, and we'll explore those concepts in more detail there. I hope you found this video useful, and I will see you at the next one. Hi there, and welcome to this lecture. In this video we will look at the difference between require keyword and use keyword in Perl to load modules in your code. Now the very basic key difference between use and require statements are that require is for requiring a module at a runtime, and use statement is for using a module at compile time. Now let me quickly demonstrate. Let's try to use a module that does not exist. For example, I do not exist. And hopefully you haven't installed module with such name, otherwise this will work, but I will trust that you haven't. If I save this file, run the script, we're going to see that I do not exist in includes path. And we looked at the includes before, and we know that these are all the paths where Perl can look for the modules, and if it finds it, it's going to include it in our code, and all is going to be well. However, in this scenario, we don't have such a module, so it's going to break all the time. Now let's introduce a logical statement. For example, if I say if 1 is larger than 2, only then I want to use this module. So if I move it down here, save the code, and run the script again, it's going to complain again. And this is because even though we're using this use statement in the logical expression, we have to remember that use statements are always executed in these begin blocks that we looked at before, meaning these begin blocks are going to run before any other logic at compile time. And as I mentioned before, the use statement is nothing more than a shortcut for requiring a module, which would be I do not exist. Now talking about requiring, let's remove the begin block and let's change this to require I do not exist. Let's rerun our code and this works. You might be thinking, well, maybe this require actually doesn't do anything and I'm just talking nonsense. However, if I do remove this if statement and rerun the code, we're going to see that Perl tried to find this module in our include path and it couldn't. Now this brings back to the key difference I talked about. So use is always going to be executed at compile time via the begin block, and require is going to be executed in runtime. So you can require modules conditionally. Well, you might be wondering why you would prefer using require over use and vice versa. Well, it depends. Most of the time you will most likely want to go with the use statement if you know beforehand that the module being loaded definitely will be needed in your code. However, for example, there can be times where you work with data, you want to do extra processing on values conditionally. If that extra processing logic is isolated in a module and you don't know if you'll need it, then you can require a module during runtime to pull in the necessary code, as we did with the example before, where we said if a condition passes, we want to require a module, which in this case does not exist. Let's look at other key points. The burning question probably is, how does this all work behind the scenes? Well, it's nothing really magical. As we saw before, Perl has this inc array, which stands for includes and holds a list of paths, where Perl can find modules. Now when you use a module, for example, data dumper, as we have been using it before, what Perl is going to do, it's going to convert the two columns to the path name and append the PM file. So basically, use data dumper becomes data /dumper.pm, which then is being looked at inc folder for all the paths in there, going to look for base path and is going to append the module name, which is the data dumper, and try to load it from there. So if we explore some of these paths, such as here, and we have a couple of paths, so hopefully the module we're looking for is going to be in the first one. If I do ls on this path, and if I look here for data dumper, well, data, looks like it's not here. Let's check the directory before. Is this one. If we ls this and try to go into data, here we go. We see data dumper.pm. Perl retrieves the logic of this file from this path, which is the lib 5.36, the current Perl version we're using, or higher, depends when you're watching this video, and then one further path up, and then the data folder, and then the dumper PM. So we saw that this path was in our includes folder, such as this, and the data dumper was simply appended to it. Now if we bisect this even further, I did mention before as well that when you use the use keyword, what happens is behind the scenes, Perl is actually calling require, parsing the module name as data /Linux/ or depends on your system, ending with .pm. So in the end, it would look something like this. Another key difference is that when you use the use statement, it's going to call the module name, which is data, dumper, and import, which is going to get a list of method names you want to import from that module. Or if no method names are provided, it's just going to export everything by default. Let's see an example. If I just comment this out for the time being, and I do use data dumper, and I'm going to print out the dumper and just a string test. Save this, run the script, and as expected, we're seeing the test string. Now if I change this to require, which should technically still work, rerun the code, it's actually going to complain that Perl could not find the method dumper in the current main package. And we know that the main package is referring to this script. So basically, there is no dumper method defined in the current package. So this is where this import method comes into play. The require, by default, does not import all the default exported methods. And going back to the use statement and the import functionality, you could also explicitly specify that you want to import dumper method. If we rerun this, we're going to see that this works as well. And vice versa, you could actually provide an empty list and say that you don't want to import anything. If we rerun the code, it's going to complain again that dumper method could not be found. So that's another key difference. When you're using a use statement, just remember that it's always going to get executed at compile time through this begin block. And it's going to convert the module name with a colon to the path based on the system, and it's going to require that module. And additionally, it's going to import all the default exported methods unless, as you looked at here, you explicitly specify the methods you want to import from that module. But here we're not importing anything at all, and we're trying to use a method that actually does exist in data dumper, but it's not being imported. Or if I try to import something like does not exist, save the file, rerun it, it's just going to say that does not exist is not exported by the data dumper module. And this is quite handy, for example, if you only want to work with specific methods from modules and you don't want to import everything that the module offers. Or even further, if you want to use the fully qualified module name to call a method, such as this. So here it might be confusing because the method is also called dumper, but all that's happening is that we're saying that we want to use from this package data dumper a method called dumper. Even though we're not importing it explicitly, you can still use it by referring to this module. And to come back to this conversion from colon to path separators, you could change this to require data, replace this with forward-leaning slash, add .pm at the end, and try to call this method again. Oops, we forgot semicolon. Let's save this, rerun it again, and it works. So here you can see that we are importing a module based on the path, not the package name. Now the require is also quite handy if you want to import other scripts, because by default you can't use scripts in other scripts through use command. Let's look at this. So if I remove all of this boilerplate, and I'm going to introduce a new file, and I'm going to call this script2.pl. Now let's add the shebang line, so user bin environment Perl, use strict, use warnings, and it's a good practice to always write this out. Let's add a truthy value at the end to indicate to the Perl compiler that requiring of this script file succeeded, otherwise we're going to get complaints. And let's add a method such as sub hello from script2, and all this is going to do is going to print here with new line. We save this, we go back to the script1, and we try to use this script2.pl. As I mentioned before, this is not going to work. So it says there's a syntax error. This could not even be parsed. However, if I replace this with require, save the file, rerun it, there are no complaints. So now I can call the method, which was hello from script2, save the file, rerun the script. Oops, and we forgot the extension, so script.pl, and we're going to see heya printed to the console. So this is it for this video. We looked at core differences between loading your modules using required and use keywords, how loading modules and scripts work in Perl, and when you would opt in for one or the other module loading method. I hope you found this video useful, and I will see you at the next one. Hi there, and welcome to this lecture. In previous video, we looked at what's the difference between using required and use keywords. We also looked at how we can import default exported methods from modules, or we can explicitly define which methods we want to import, such as the dumper method from the data dumper module. Now in this video, we're going to explore how we can actually build our own methods we want to export from our modules. We're also going to look into what's the difference between class method and a static method. Let's get started. Now let's introduce a new file, and to be precise, this is going to be a Perl module file, and we're going to name it our module and .pm for Perl module, and in this file we want to declare the package name, which is our module. We also want to return a truthy value, we want to use strict, and we want to use warnings, which is always good practice to do, and we also want to introduce a method, and let's say this method is going to be called addNums, which is going to take two numbers, let's say num1 and num2, and we're going to get them from our argument list, and what we're going to return is num1 plus num2. Now let's save our module file, let's go back to the script file, and let's try to use our module. Now let's run the script file, let's provide capital I flag for including module paths, which is going to be our current directory, noted by ./, and then we're going to run our script file. So we need to save it, and if we run this, all looks good. Now, let's say we want to call this function called addNums. So I'm going to invoke the method addNums, and I'm going to give two numbers, 3 and 2. And I'm also going to print it out to the console. If we go back and try to run our script file, it's going to complain that addNums subroutine is undefined, and that is true because currently we're not importing anything from our module, and this function addNums is not defined in this script file. So Perl simply doesn't know what we're trying to do when we say addNums. Let's go back to our module file and let's use this module called exporter that we haven't used before. So use exporter, and we're going to also import the import method from the exporter. Now, if you remember from the videos before, when you're calling use, two things happen. Perl is parsing your module name by appending .pm at the end of it to import logic from that module, and it's also calling this import method to import all default exported methods. So here, we're requiring import method from exporter, which will be called on our module to export all the default exported methods. So how you define which methods you want to export is by using keyword or, and then this array called export, where you provide the list of methods you want to export. So addNums in our case. So if we save this, go back to our terminal, run the script file, as you can see, number 5 is printed out to the console. And this is because now, when we're calling the addNums from our script file, this method is imported by default from our module. As before, if we said we don't want to import anything from our module, rerun the script, is going to complain about not being able to find the function addNums, where in order to call this explicitly, we need to provide a full qualified package name, such as our module : addNums, and if we run this, this is working again. So this is how you can export methods from your module file. Now, one thing you're going to notice is that previously, when we were building our classes and instance of the classes, we got this class keyword, which is not the case now in our addNums function. And this is because we're not initializing a new instance of this module. We're simply using addNums function, using these two colons. So this is called a static method. The key takeaway here is that when you're using static methods, you're not getting the class name automatically provided as the first argument. However, if we would be needing the class variable in our function, we could call it with arrow notation. If we save the script file and go back to the module just to print it out. So let's print out the class, let's append a new line, save the module file, we run the script, we're going to see two things. Our module printed out, and then the number 5. So this was the first print statement, where we automatically got the class name, and in our script file, we're printing this method addNums, which adds two numbers. So there's the difference between instance method, class method, and static method. The instance method is called by initializing a new instance from a class, where you're getting the self context, the given attributes, also the class name, and etc. And it's being invoked by this arrow function. Of course, in this scenario, we're not actually building the attributes and the self, and we're not also blessing the self hashref with the package name. However, we're still getting the class name as the first argument, since we're invoking it with an arrow function, and that's why it's called a class method. Now the final method, which we called initially, was with these 2 colons. We would save this, rerun the script. What you're going to observe here is that actually number 3 was printed out, and then a warning about that we're trying to use uninitialized num2 in addition in our module. So what happened now is that the first 2 arguments, which are class and num1, were taken directly from our script file as the arguments we passed here. So we're never getting the num2 as the 3rd argument, and instead we end up printing out the class name and trying to add num1 variable, which would hold number 2 in this case, and then adding number 2 variable, which currently is undefined. Now to quickly go back on the export methods, alternative of using this @export array, you could use export_OK. And if we remove this class name and print class name and just return the sum of 2 numbers, we go back to our script, and let's also remove the package name and save this file, run it through terminal. We're going to see that addNums function wasn't defined. Actually, we also need to remove the quote word for explicitly not importing it. Save this, rerun it again, and we're still seeing that warning. And the difference here is when you're using export, as we did initially, without the _OK, all the methods in that array are going to be exported by default. When you're using _OK appended to export, these methods are not automatically imported, meaning you need to explicitly import those methods you're exporting from your modules. If I save this, rerun the code, it works again. So this is it for this video. We looked at how to use exporter, what's the difference between export and export_OK, and we also took a step back and we looked at what are instance methods, class methods, and static methods. Now when you use each is really up to you. And the use case, by the end of the day, really depends on scenarios what you're trying to achieve. Sometimes you just want to encapsulate a logic which does a very simple thing, such as adds 2 numbers. In that case, you don't really want to initialize a new instance of an object, and you can simply use a static or a class method to do anything that doesn't require a self context. Now, when you need a self context to access attributes that have been initialized by creating an instance of a class, then you would use an instance method and access the current self-context. But again, it's really up to a use case. And it's up to you when to use the different accessors at different times. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video, we will look into how we can install Perl modules using CPANM, aka CPAN-, the Perl's package/module manager. Before we begin, I would like to note that Perl actually already comes with package manager called CPAN, that is, without an M at the end. So this begs a question, why would we be using something that's called CPANM instead of the default package manager? Well, think of CPAN and CPANM being exactly the same. They both are needed to install and manage Perl modules. However, the CPANM requires no configuration and is much less noisy in comparison to CPAN when installing modules. Also, it is incredibly easy and quick to install CPANM when using Perl, so there's really no reason why not to get it on your system. Now, to install CPAN on your system, you want to go to your terminal and you want to type Perl brew, and what are you going to get is a bunch of commands related to the Perl, and so on. What we're interested in this case is a command that says install CPANM. So let's run this. So if I copy this command and type Perl followed by install CPANM and run this, it's literally going to take a split second for CPANM to be installed in your system. Or you can verify that this is running, you can do which CPANM, and this is going to give you the absolute path to the CPAN binary. And that's it, easy as that. We now have CPANM on our system, which is going to be automatically initialized on the new sessions. We're now ready to install some Perl modules. Now how you can install modules is by typing cpan --help to get a manual page, and here we can see to install a module, we can simply run cpanm and the module name, which is going to install a module on our system. Now there are other options you might want to run your installation with, which is this verbose option that kind of tells you more information of what's going on when you're installing a module. You can also force install modules in case there are some dependency issues, but you're fairly certain the module is going to work anyway. And usually when modules are being installed, they also run tests, and you can specify a flag not to run those tests. And you can also install modules from a file, which is quite handy because you can keep track of all of your modules in a file and then run cpanm install deps and provide a cpan file, which has all the modules that needs to be installed. And there are others to explore, but we will focus on the simple command, which is cpan and the module name to install a specific module. The official Perl module repository is located at metacpan.org, so let's go there. If I search in Google metacpan, I'm going to see this link, which is metacpan.org. We go there, you're going to notice that it's quite minimalistic and it's straight to the business, so to say. You're met with a single search bar, and you can use this to browse the massive module ecosystem. Let's say I wanted to find a module that can help me with converting between JSON string to href structure and vice versa. So what I could do, I could search for JSON, and what I'm going to see here are a couple of options presented to me. It might be overwhelming at times and you might not know which module to pick, but most times you can simply choose a module which is at the top of the list. And if you want to find more information about that module, you can of course browse the name of it, see how much is being used to understand if it's the best fit for the job. Now if I select this JSON access, I'm going to be taken to the documentation. And usually the module documentation on metacpan is excellent. It gives you some examples of how to run this module, general description, any pitfalls, so on and so on. It's always good practice to read the documentation to understand if the module you're looking at is actually suited for the job. In this case, at the top of the page, I can see it does two things. It encodes a JSON, and supposedly it provides a JSON text, and it also decodes a JSON text, and provides a href or arrayref. All depends on the JSON structure. But at this point, I'm fairly certain that this is what I need. Now to install the module, let's copy the name. Let's go back to the terminal and simply run CPANM, and then the module name, which is JSON::XS. So I run this. This is going to take a couple of seconds to install, and that's it. It shows that the module has been installed on our system. Well, to be more precise, it's installed into location where the Perl brew manages all the modules installed for the current Perl version we're using through the Perl brew. So again, this is why the Perl brew is quite useful, because it keeps the things isolated from each other. Now, if we go to our editor, and let's say we want to use this module. Now, how you do that is by using this use keyword that we explored before, and then the module name, which is JSON::XS, and we can save the file. If we run this with Perl script, nothing happens. This is because we are using the module, we're not getting any complaints that this module could not be found, but we're also not using any functions from this module. So let's go back to the documentation. And here we can see that we can call encode JSON, which we don't need to explicitly import from JSON::XS. So I copy this name, go back to the script. Let's try to print out a href that is a valid JSON structure. For example, if I print dumper, and I'm going to wrap around the encode JSON function, and in this encode JSON, I'm going to provide anonymous href. I'm going to end this with semicolon, and let's say I want to encode A key, which holds value 1, and B key, which holds value of 2. If I save this, run the script, and here we go. We can see that this is a string printed to our terminal with two keys, B, value 2, and key A with value 1. Now the documentation also states that we can decode JSON, so let's try that. If I copy this method name, go back to the editor, and instead of encoding a JSON, I'm going to use decode JSON. Now here, what we can do, we can copy the string, which we encoded before, and provide that instead of a href structure. We save this, run our script. It's going to convert from a JSON string into a href structure. So by now you probably have noticed that arrayrefs and hrefs are quite similar with the structure of what is considered a valid JSON. So if I wanted to decode, for example, JSON array that holds a simple string A, save this, go to the console, you're going to see that this is converted into arrayref with a single value of A. So it's quite easy by nature to convert between Perl data structures and JSON structure. Now you're probably wondering, how can you find installed modules on your system? Strangely, there is no straightforward way to do it. One of the options is to use another module, which is called extutils installed. And this module is going to give a list of modules currently installed on our system. So if I go to the documentation and look for extutils, installed, which is the second option, copy the module name, go back to the terminal, and if I say CPANM, install this module, we're actually going to see that this is one of the core modules, so you don't even need to install it. So if I go to my editor and use this module by extutils installed, it has a method which is called modules that we need to call on a new instance of this extutils, and it's going to return a list of module names. So what we could do, we could print dumper And inside the dumper function, you could say ext utils installed new. So we're initializing a new instance of this class, and we chain a method on this new instance called modules. If I save that, go to the terminal, run the script. Here we go. We see a couple of installed modules in our system. Note that we don't see stuff like exporter that we looked at before or data dumper. And this is because this module does not list the core modules of Perl. It only lists the ones that we have installed on the side. It's still quite handy utility to know what's installed on your current Perl module path. This is it for this video. We looked at where to find and install Perl modules. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video we will explore a better way of handling exceptions in Perl using two modules, try-tiny smart catch and exception class, instead of using eval and die functions as we saw before. First of all, why would we want to use modules to handle exceptions instead of using the good old baked-in error handling in Perl? Well, some very valid reasons would be that maybe you would like to execute some additional logic in your code when a known exception was thrown, or you might want to log exceptions with different priority based on exception type. For example, if a user enters invalid password when logging into your app, you might want to throw invalid password exception. And of course, there's plenty other scenarios. Using die and eval and maybe some regex could achieve this organization of error layers. But trust me, that would be a huge mess real quick. And by the end of the day, we don't have to do it because we have some very awesome tools at our disposal. As I mentioned before, the first module is called try-tiny smart catch, and it basically allows you to catch errors in different blocks by package name, regex, exact errors, and handle unknown exceptions. The second module is exception class. This module allows you to create custom named exception objects with attributes and other goodies that massively allows you to enhance the management of errors. Let's start by installing these modules. Now the first thing you want to do, you want to go to meta CPANM, and what you want to search for is try-tiny smart catch. So if you open it up, you're going to be presented with quite detailed documentation, and I highly suggest you to read through it to understand bits and pieces that maybe we will not touch on in this lecture. And that stands for every module. If you don't understand something or you would like to try additional functionality, it is highly encouraged to check the documentation. For the time being, let's copy this name, try-tiny smart catch, and let's go to our terminal. Now, I'm going to use my editor's terminal to install this module. So CPANM and the module name. And it was pretty quick to install. Now the next module that I mentioned was exception class, and it's written as exception : class. So here it is in first suggestions. Again, as before, you can check the documentation if you want to find out more, but for time being, let's just copy the module name. Let's go back to our terminal and let's install it as well. This is going to take a second or two to get installed, and I'll see you once it's done. Now the modules are done installing, and we are ready to use them in our code. However, before we proceed, I would like to have a quick refresher on how we throw and handle errors in Perl. So if you remember, we use this keyword called die, then followed by a message. For example, I can type "this is it." If we run this, and maybe let's add a print statement. If we say something like "hello," save our code, go to the console, run the script, and we're going to see this is it without hello being printed out. Now if we use the eval keyword and wrap around our die statement, save this, we're going to see hello printed out because the die was handled. And to print out error, we can use this special variable with $@ symbol. If we save this, we run our code, we're going to see that we print hello, and in this variable we have the exception that was thrown, and also it indicates on which line it was thrown in our script. Now this is the old way. Let's see how we can handle errors in a new way. So first of all, we need to use both of our modules, so let's do that. So the first module is called try-tiny smart catch, so use try : tiny : and smart catch. And the second module is called use exception class. Now let's start by handling exceptions with try-tiny smart catch. What you can do, you can type this keyword try, followed by sub, and you can put your code in here, in between this try sub block. Now to catch general errors, we can use this catch default, followed by sub, and all the errors that are going to be thrown, which we do not handle in a specific way, are going to end up here. Now for example, if I say error that we receive is in this local context denoted by $_, and here we can throw, for example, die, this is it. If we save this, run our code, oops, and looks like we forgot one of the colons, so exception : class. We rerun this, and what we're going to see is this is it, which is exception that occurred on line 14. Now, this doesn't seem really useful at this point. I mean, we are throwing errors, we're just catching them by default. So what's the big deal with this? Now, the real power comes with using these in conjunction with exception class. Now, how you construct custom exceptions with exception class is by you provide a list context and you define your new exception. For example, my exception. And we can see this here in the construct as given example. So all we need to do is we also need to wrap it as a string. Your exception name has to be a string. Now the question is, how do we use them? Well, you use custom exceptions by writing my exception, or however you named your exception, and calling a method, which is going to be inherited from the exception class called throw. And here, if you look at the documentation, you can throw exceptions with specific messages. So what we could say is, for example, error, something is not right. Now if we do this, save the code, rerun our script, we're going to see something is not right printed to the console. Okay, you might be wondering, right, we're throwing custom exceptions now, but there's not much difference, so I still don't see the point of them. Well, we have to go back to the try-tiny smart catch and explore the documentation there. If you look at the documentation, you're going to see that you can actually catch specific exceptions. So, for example, here we can write something like catch when, exception name, and a subroutine. Let's do that. After our try block, and before the catch default, which is the handler for unknown exceptions, we can write something like catch when, then the exception name. In this case, this is my exception, followed by its arrow notation, which takes subroutine. And here we can do something like say, I know this exception, exclamation mark. Now if we save the code, rerun it, and here we can see that we actually printed out I know this exception, instead of just falling into the catch default block. Now imagine in your code you have different scenarios, such as you could not connect to a database, or you could not parse a JSON, or your file system is full, or so on and so on. Maybe these are exceptions you want to recover from. In that case, you can add as many catch when blocks as you want, for example, my exception, and let's replace it with something like app, file system, full. Let's copy this exception, add it here, and let's quote it. And now instead of saying my exception throw, we can do app, file system, full, and throw. And we can say something like, oh no, the disk space is full, exclamation mark. Let's introduce two scenarios. For example, if we use a conditional statement like if, now I'm going to say this random, which we looked at before, 5, is larger than 2, then we want to throw this exception. Else, we want to throw my exception, throw an error, something else. And instead of here, we could actually print out exceptions themselves. So I'm going to replace these. Maybe I'm actually going to put them in a string context, so we have a better visibility instead of the full stack trace. So let's wrap this context with string as well. And if we go to our terminal, run the code, we're going to see something else. Let's run it again. Still something else. Oh, and our exception changed, because there's a chance that if this random number is larger than 2, we're going to throw this specific exception. Otherwise, we're going to throw the my exception. So here, the first 2 times, we threw the something else. And the third time, we actually threw the disk space exception that says the disk space is full. Hopefully you do agree that handling exceptions this way is much better approach and gives you much more flexibility than just simply putting die statements in your code and trying to reject specific exceptions. We're not going to go into too much detail on this. However, just know that in our exception class, we're not just restricted to saying error something. We can also add our own attributes that we can get on the current context of a known exception, do some additional logic. For now, what I'm demonstrating here is that when you throw specific custom exceptions, you can handle them in different ways in a very trivial approach that is just so much better than throwing exceptions in the default Perl way. Now this is it for this video. We looked at how we can do much better exception handling using try-tiny, smart catch, and exception class modules instead of the out-of-the-box die and eval functions. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video, we will look at how we can make web requests and parse responses using Mojo UserAgent. First of all, why are we using Mojo UserAgent? Just to clarify, there are definitely other modules in MetaCPAN ecosystem that allows to make and parse web requests. However, I find Mojo UserAgent to be very user-friendly and feature-rich. And this is what the Mojolicious framework is using behind the scenes. So it's definitely a solid choice. Mojo UserAgent includes some of great features like parsing various content types, for example JSON to Href, sending and receiving data via WebSockets, and probably one of the most awesome functions, async requests using promises. If you come from JavaScript background, you might be very familiar with these. However, if not, in summary, promises are non-blocking async tasks you put in background while running your code, and they will resolve, so to say, once the task has been completed. If it does not make sense, no worries, we will look at a basic example in a minute. Now as before, where you want to start, you want to go to MetaCPAN and you want to look for Mojo, UserAgent. So if you open this up, as before, the documentation is quite good here and it gives you a lot of nice examples of how you can run them with promises in async, even how to use WebSockets, and running multiple requests in parallel. But one step at a time. Let's start by copying the module name, going to our terminal, and installing it. So as before, CPANM and the module name, and we're gonna hit return. This is gonna take a minute or two, and I'll see you back when it's done installing. Now the module is done installing, and we're ready to proceed running some web requests. So where do we go from here? Well, as before, we want to start by using the module. So use Mojo UserAgent, and let's save our file. Now let's go to our browser. And what I'm going to be using is this website called JSON placeholder typecode. So basically what this website is, it just kind of gives you these mock responses in a JSON format. And this is exactly what we want to do. We just want to test simple web requests using get to fetch some posts, for example. So I'm going to be using posts, and we can see that if we access posts, we're going to get 100 items, and we can also access specific posts with /1, /2, and so on. Let's copy this link, which just accesses the first post, and let's go back to our code. Now here, I'm going to declare a variable. I'm going to say my post, and I'm going to set it as a string, and here I am just pasting in the link we just copied from our browser. Now, how do we call this URL? Well, we need an instance of a user agent, and as you know from before, you get instances from classes by calling method new. So what we can do is we can say my UA for user agent equals Mojo user agent arrow notation new. And now we have access to functionality of this module on this instance. Now let's see how we can make a GET request. If you go back to documentation, we're going to see that in order to get data, we need to call method get followed by the URL, and we also need to call result. So let's try to do that. If we print something out from UA arrow notation get followed by the link, which is stored in our post variable, and then call result, which is result, semicolon, go to our terminal, run our script, Perl script.pl. It looks like we actually need this additional package to be installed in order to run secure requests. So since we're calling HTTPS, we need IO socket SSL to be installed on our system. So let's run CPANM IO socket SSL. Let's wait for this to finish installing. Right, and this is perfectly normal. This is actually great that we're getting these errors, because now we can look together into how we can resolving these dependencies. Now let's see if we can install this module. So if we do CPANM, run net sslia, wait for this to finish installation, and looks like it failed again. Perfect. I mean, this happens all the time, and no need to be scared or throw in the towel and give up. So let's look at the build log. I'm going to print this out, what's in the build log. It's going to say could not find libSSL headers. And looks like we're actually missing OpenSSL required files in our system in order to install this package. If you do get an error about not being able to install that TLS module, and if you're on Mac, what you want to do, you want to run this command you can see in the terminal, which is brew install OpenSSL, and that should take care of all of the dependencies needed for that module. So I already have it installed, and I sanity checked if everything is working, and it is, and hopefully it's going to be working for you as well. However, if you are on a distribution like Ubuntu, what you want to do, you want to run this command, which is sudo apt-get install libSSL dev. Right, so hopefully the installation finished for you without any issues. Let's try to run our script again. And I did not install the full module yet. We run the script, and yes, it says that IO socket SSL is missing. So if you rerun the installation, so CPANM, IO socket, SSL, run this, let's wait a minute, and that should be fine. And I'll see you back once it's done. Right, so the installation finished for me without any issues, and hopefully it's the same for you. But if you're facing any difficulties whatsoever, please do leave a comment and we can look into it together. Right, after all this hustle, let's go back to our script and let's see if it's working now. So Perl script.pl, if you run this, what are we going to get? Right, so we see that this is actually an instance of an object. So here we're printing out an instance of something and something being message response. Now the question is, what are we missing to actually get the body of the response? Well, if we go back to the documentation, we can see here in quick JSON API request with basic authentication, we don't really need the authentication part, but from the example below, we can see we're calling result that we are doing in our code as well, but it looks like we're not actually calling JSON method. So it seems that when we're calling result, we're getting back an instance of response, and there's also a method to request the parsed JSON body. So let's do that. Let's call the result and arrow notation JSON, save that, try to call the mock IPA again, and we're going to get hash. Well, this looks better because this is actually now a hash ref. So that just means we want to print this through dumper. Because if you're just printing a hash ref, we're going to get the reference in memory as we saw before. So that's why we need to use the dumper. Third time the charm. Here we go. We got back a JSON body which was parsed into a hash ref, and this looks all good. You can use other potentially quite useful methods on the result itself instead of just getting the body directly. For example, I could save the result into result equals UserAgent post result, and without calling JSON, let's just say some stuff such as result is success, and also let's copy this line and call this method code, which is going to give us the status code, and let's save that, rerun the request. If only I could spell success, we're missing one S. Let's save that, rerun the request, and here we go. We can see that this request was successful because we got a truthy value back, and here we can see the HTTP code for the successful response, which is 200. And you're not just limited to GET requests. You can use PUT requests or the POST requests. You can submit form data, or you could submit JSON data. Depends on a use case. Which exactly type of request are you looking for? And the examples here are really great. You can find a blueprint for pretty much anything you want to do with Mojo UserAgent. Now, let's look at something more a little bit advanced. I talked about these promises at the beginning of the lecture. I did mention that promises allows us to make many requests in parallel without blocking the execution of our code. Now, let's put that into practice and see if it's really true. Now if we remove this print part and just simply try to get the same URL a couple of times, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we do this, we're going to reach out to this URL 10 times in a sequential manner, right? So this first request has to succeed, the second request has to succeed, third one, and so on. Let's run this. And let's also remove the variable names because we don't really need that. We don't want to store results. We just want to reach out to these URLs and see how long it takes. To time something, you can use this system time command. So let's use that before Perl and run our script. Right, it took 8 seconds for me to call 10 URLs for the post one. Might be faster for you, might be longer, depends on connection. But average for me is 8 seconds. My net is not that great. I think that is quite true. Right, the question is how we can improve this. Well, if we go back to documentation, which is again pretty great when it comes to showing examples, you can see that there's a comment saying concurrent non-blocking requests synchronize with promises. Well, that looks promising. So let's keep in mind that we can call the same methods as we did before with get, but we just need to append _e for promise. Now let's go back to the code. Let's replace this example with something else. I'm going to construct a couple of promises that we want to resolve in a synchronous manner in our code. So what I'm going to do, I'm going to declare a new array called promises. I'm going to call a map function, and I want to call this map function from 1 to 10 elements. Basically, this is going to give us a new list for 1 to 10 items, depending on what is returned in the map function. So in the map function, I'm going to do UA, UserAgent, get _p for the promise. And here, what I want to do, I want to copy the URL that we called before, which is the posts with number 1. I could of course append a different post number using the current context by $underscore, but I'm not going to do that because we did look at example using the post ID 1. It's only fair that we use the same IDs. So now how we can actually get results back from these promises, you need to use another module, and this is going to already be installed. When you install Mojo UserAgent, it's one of the dependencies, and it's called Mojo promise. What this module takes is a list of promises, and how you construct this is Mojo promise arrow notation all, where you provide the promises, and then you type then. And in that then function, it expects a function. So sub, this is just anonymous subroutine. There's nothing really special about this. We're not assigning it to anything. We're just providing anonymous subroutine. And what we can do here, we can get all the promises that have been resolved in a list, but we don't actually need the parentheses since we are accepting a list. And we're going to get this in the argument list, and we have seen this many times before. And this list is going to be populated by this then method. But the question is, what are we actually getting here in this resolved? We're going to be getting back the response object exactly the same as we did get from calling the getLink once. So we had to call the result, and then we had to request decode the JSON body. What we could do, we could say dumper. I want to say this for every single result promise, which is the response. We can use a loop, which is for. Same as with if conditionals, we can use some of the loops after the declaration of our code. So here I'm going to say for resolved. And what I want to print out is the current context, which you're getting from this loop. Each item in resolved, as I mentioned, this is the response, but it also contains other elements in this resolved. So I'm going to access the first item in the resolved list, the result, JSON, and save this. If you rerun our script with time function, we're going to see that we have a syntax error. This is because we're missing a semicolon after then block. So let's add a semicolon, rerun this, and looks like nothing happened. This is because we are actually missing another call after then chained function call. If you look at the documentation, what you also need to do, we need to call the wait to await our promises, which we're not doing. Let's add this wait call as well. Let's chain it after then and rerun our script. Hey, looks like it took only 4 seconds from doing all of these calls sequentially one by one. So we literally reduce the time to make these requests by half, which is amazing. So this is it for this video. We looked at how we can make web requests using Mojo UserAgent, parse a request response, check the status codes, and do some very awesome things like making multiple async requests using promises. I hope you found this video useful, and I will see you at the next one. Hi there, and welcome to this lecture. In this video we will explore how we can write and read files in Perl using out-of-the-box tools. And we'll also look into using Perl module called PathTiny, which gives a nice and easy to use interface to work with files. However, let's start with looking into how we can write and read files using solutions given by Perl. Now to write a file, you can use this open function, and this open function takes 3 things. It's going to take a variable, which is going to be a file handle, and the next is going to be a symbol that indicates if you want to read a file, append a file, or overwrite existing file content. Now here what we can do, we can try to write something to a file to our current location from where we're running the script, and I'm going to call it test.txt. Let's end this line with semicolon. Now the first thing you usually want to do, you also want to call the close statement on the file handle, but you don't want to end up having multiple open file handles, which can lead to memory leaks. So it's a good practice to always open and close your file handles, even if you want to move them to different lines later on. It's just good to have it there for visibility and a reminder. Now let's end this line, and now to actually write something to the file, we can use print. And instead of just printing something like hello world, to the standard output, we can actually provide a file handle. And what's going to happen, instead of printing to the standard output, we're going to print to this file handle, which is going to write something to our file. If we save this and run our script, nothing happens, but that is good because we're also not seeing any warnings. However, what we're going to see that there's a new file next to our script. And this file is called test.txt. Quite conveniently, the file also was created at the time of being written to, so we didn't have to take care of that. If we open this file, we're going to see hello world. Now let's say we want to write multiple lines. What I'm going to do, I'm going to copy these print statements a couple of times, save the file, run it again, And if I go back to test.txt file, I'm going to see multiple lines printed to the file. Now, what if we actually had something in the file already? Let's say I already exist and save it in our text file, go back to our script and run it again. And let's go back to the file, to the test.txt. What we're going to see is that what we had originally in our file was actually overwritten. And this is because when we're using this greater than symbol, what's going to happen is that content of that file is going to be overwritten. We did see many hello world lines, but this is also because we are working with a single file handle. So everything is written to that one file handle, which is then saved to this file. Now, that also means that alternatively, we would need to read the file contents in, reprint them to the file, and then append the other lines we want to write to it. But there's an alternative. What you can do, you can use these two greater than symbols. Now if we save this, and I'm going to add new line character at the end of our hello world lines, and if we go back to the test file, and let's reintroduce something like I already exist. If we save that, go back to our script, rerun it, and if we see our test.txt file, now what happened? We actually preserved the original content. So that's the difference between one greater than and two greater than symbols. So if you're using one greater than symbol, it's going to override the contents of the file. However, if you're using two greater than symbols, it's going to append to the file. And that's exactly what happened here. So we already had a content and we just appended our new hello world lines. Now, the question is how we can actually read the content of a file. It's quite similar to writing to a file, but we use less than symbol. And how we can store the content of the file, we can declare a new variable, for example, my content equals, and we haven't seen it before, but we can also use this do block. And what the do block allows you to do, it allows you to define the logic you want to execute, very similar to function, but the difference is that do block is actually going to turn a value at the end. So here we want to return all the content that we read in our file. So how we can do that is by saying local $/ and this line. And then we provide, similar to taking an input, what we saw with the diamond operator, instead we can define that we want to take the input from this file handle, which we opened before on this line. Now, if we print out the content through say content, save the file, run the code again, we're going to see all the content printed to our console. Now let's quickly explore what is going exactly here. We have this local $/ and file handle. To put it simply, we are just setting this Perl special variable to undefined, and we're setting it undefined locally in this do block scope. If we wouldn't do that, for example, if I remove local $/ and rerun the code, we're just going to see the first line that we have in our file, which says I already exist and hello world, that we can see here. Now the reason why we want to localize this variable and set it to undefined is because otherwise Perl is just going to read the input up to the first break line and it's going to stop reading the file. If we set this special variable that indicates the end of the line to undefined, it's going to read all file. You might be wondering, well, why can't we just set this variable to undefined in general? For example, before the code, such as this variable equals undefined. And if you rerun this, it does work. But the problem is that we are affecting the scope of this variable. If we wanted to read different lines of code, or if we wanted to take input from the terminal, this means we have modified this special end of the line indicator because we're setting the scope globally. All we want to do by setting this special variable to local in this do block scope to be able to read contents only of this file specifically without modifying the special variable end of the line indicator globally. And this is how all of this comes together. Here in this do block, we define logic that we want to execute in isolated scope. In this scope, we localize the end of the line variable to be undefined, meaning we want to read the full file content, which is currently held by this file handle. And we can do this by telling Perl that the end of the line separator should be undefined, meaning read in all the file. And also, as I mentioned, the difference between if conditionals and the do block is that the do block returns a value at the end of the execution. The meaning is going to return all the contents that was read in from this input. To put it simply, we're just doing this to be able to read in the whole file. Through this file handle, we opened up on this line just above the do block. Now there is one pitfall. Reading in contents of a small file is perfectly fine through this approach. However, if you have files that go into hundreds of megabytes or even gigabytes, do note what we're actually doing. We're reading the file in the memory. So this might not be the best approach you want to take. If you are dealing with huge files, what you probably want to do, you actually want to read the file contents line by line. And in order to achieve that, you can use the while loop. So let's replace this do block with while. And what we're going to add in this while loop expression is going to be the find keyword. And here what we're going to do, we're going to say my line equals current line from the input of the file handle. Now what we could do then, we could define a new content variable with an empty string. And here in the while block, we could say that we want to append to the content with dot equals the current line. And then we want to print out the content. If we save this, rerun our code, we're going to see that the content holds all the lines we read in and appended to this content variable. Alternatively, we could instead print line and the current line we're iterating over. If we save this and remove the content variable and rerun the script, we're going to see that we read in each line and we printed it out, followed by two new lines, because the lines we have in the file ends with new line, and then we're saying something which also adds a new line. And this is an excellent approach in case you want to parse the large files line by line. And honestly, that's probably the approach you want to take most of the time instead of reading the whole file in one go. Right, so this is it for this video. We looked at how we can read and write files in Perl using out-of-the-box solution. We know how to write to the files, append to the files, and read the files. However, in the next lecture, we're going to explore alternative, and that alternative is using a module called PathTiny, which gives you a very nice interface to interact with all of these actions where you want to write, read, append to files, and you don't need to think about these internals of localizing things and keeping of state and so on, because that's all managed by the module. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In the previous lecture, we explored how we can read and write files in Perl, and that's perfectly fine to use the out-of-the-box approach for trivial tasks to read or write to files. However, you might have noticed that there's a lot of low-level things you need to keep track on in order to take the out-of-the-box solution when it comes to managing files, such as you need to create file handles, remember symbols for writing, reading, and appending to files, closing file handles, and so on. It would be much better if we could delegate these low-level tasks to a module that can do repetitive steps for us. And it turns out there is such a module. Well, several. But we will explore one of the most popular ones called PathTiny. PathTiny gives us an excellent and easy to understand interface to do all the actions we did before. It's light, fast, and in my humble opinion, very user-friendly when it comes to working with files. Now, first things first, in order to use PathTiny module, we want to install it. And as before, we can go to meta cpan module repository and look for path::tiny. If we open up the link, as before, we're going to be met with great documentation and it's going to give you many examples to achieve exactly what you're after. Even in the summary, we can already see some examples of how to read and write to files. And not just that, we can also read directories, which is pretty great. So let's start by installing this module. If you copy the name of the module, go back to the terminal and as before, run CPANM, the module name. It's going to take a second or two to get installed, and I'll see you back once this has finished. Now the module has finished installing, and we're ready to use it in our code. And in order to use this module, we can do the same thing we have done before. So we use the use keyword, path::tiny, which is this module's name. And what this module exposes is a method called path. And this path method takes a string, where you provide the file you want to read or write to. In this case, I'm going to provide a file which is called test.txt, and I'm going to use the relative directory. You could use the absolute directory to indicate where you want to read or write the file from, but in my scenario, I want to work with a file which is relative from where I'm running the script, which is currently Perl_course folder and next to the script.pl file. Now what this path method returns is an instance of a class that is going to have various methods that is going to allow us to read and write files. So what we can do, we can say my path and assign the return value to this path variable. And if you don't know from where this path function is coming from, I do encourage you to check the video where we talk about the difference between require and use keywords and how some methods are automatically imported by modules. Now, returning back to our example, what we could do now, we could do path and call a method spew. If you go back to the documentation, we're going to see that in order to write files, we can call the spew method that takes a list of data we want to write. In this example, we could provide a very simple list. For example, 3 strings that says A, B, and C. If we save this file, run it. Oops, looks like we have syntax error, and yes, seems like we're missing semicolon at the end of this statement. So if we add a semicolon, rerun the file, we're going to see that there's a new file that appeared next to our script file, which is called test.txt. And it contains 3 things. It contains A, B, C. Now here you can see that we actually wrote separate lines, and you would be expecting that it's going to write the lines line by line in the file, but this is not the case. You do need to provide the separator explicitly. For example, if I replace these single quote characters with double quote characters, and if we save this, and also let's add a new line at the end of each character, rerun the file, and let's see what's in the test file now. We're going to have A, B, and C on new lines. So do keep in mind that you do need to provide new line separator when you want to write your data on separate lines. Now, alternatively, if we wanted to read a file, what we could do, we can use a method called slurp. And how we do that is by declaring a new variable where we're going to store the content of the file, and I'm going to call it a content, and assign the result of path, slurp, save this, rerun the code, and we probably actually want to print out what's in our content variable. If I print out the content, save the file, and we rerun the script again, we're going to see ABC. And this is the exact content that we have in our file. Now, alternatively, you could also use a method which is called lines. So instead of just reading everything in a scalar context and just having one string, we can use lines that we assign to content, which is an array. And here we can print out through dumper \reference of the content. Just to get a better representation of what's in this array, we can just turn it into arrayref. So if we go to the console and rerun the script file, what we're going to see is that we have each line read separately, and it ends with a new line. You could of course do some processing, you could remove the new line, but if you're happy to leave it as it is, then just know the lines do read the file line by line by preserving the end separator of that line. Now you can do other very useful things with this module, and I do encourage you to check the documentation. There's an excellent documentation of each of the methods you can use to achieve things such as modifying the permissions of a file or moving a file from one path to another. This module also allows you to work with directories and list files in directories and so on. By the end of the day, this module pretty much allows you to do anything you would like to do with files, folders, reading, writing files, moving files, modifying permissions, working with different paths, so on and so on. Now this is it for this video. We looked at an alternative of how we can read and write files using a module called PathTiny, instead of using the Perl's out-of-the-box solution to work with files. I hope you found this video useful, and I'll see you at the next one. Hi there, and welcome to this lecture. In this video we will explore how we can run system commands through Perl. There can be some cases where you want to do some sysadmin tasks that, for example, requires you to list files, run some commands, or maybe you want to create your deployment scripts and you want to execute some git commands, so on and so on. There's always scenarios dependent on the use cases. Now the good thing is that Perl allows you to call system commands, and it actually allows you to call system commands in 3 ways. One way is where you can actually capture the output of the system command you run in Perl script. The second is that you can run a system command without capturing output, and maybe you want to just execute command and quit your script afterwards. Now let's explore the first scenario, where we can run a system command and capture the output of that command. You can invoke a system command by using 2 backticks. For example, here I can say ls for list, and I want to list files in a current directory. And what I could do, I could say my output equals the result of this command. If we run our script, now if we also print the outputs of what was stored in this variable, so say output, and run our command, we're going to see script.pl. So it listed and printed out the files currently in our directory. If we did that in our terminal with ls and the current directory, we can see the same thing. Now we can also make this a little bit more useful, and before outputting the contents of our directory, what we could do, we could say run a system command which is going to create a file in our current directory, which are going to call based on this context .text file for each list of numbers 1 to 10. So this should create 10 files with the names from 1 to 10 and append text to it. So if we save this and rerun our script, we're going to observe two things. The 10 files were created in our current working directory, and also we got the output from this list command. I also talked about alternatives of how you can run system commands if you might not care about the output. There's a keyword you can use called system. So what system takes is a list of commands you want to execute as strings. So for example, we could say ls, and the second element is going to be the next argument we want to run with the system command, and this would be equivalent of running ls space dot /. So if we save this, and let's actually try to capture output of this, and this equals to our system command, and if we print this out by using say output, and I'm also going to interpolate this in a string, which I'm going to add to output, save this, go to the terminal, run the script. What we're going to see is that we actually get all the contents printed out to the terminal, but do take note that these contents do not come from the variable of output that we're printing here. What we're getting in the output variable is actually 0, and 0 indicates a successful execution of this system command. Now the system command was actually run in a child process. The contents of what we see here in our terminal were printed out separately. So that is a key difference between using backticks and using system command. When you do care about the outputs and saving that to a variable, you can use two backticks and provide the command there. If you don't care about the output, you can use a function which is called system, and you provide all the arguments in a list context. Now I also talked about the third way, which allows you to execute a command and quit after execution. So let's try to do that. And it's very similar to system command. So what you do, you type exec, and let's still try to assign output of this exec command, and let's try to print it out. So if I clear my terminal, save the script file, and let's run our script again. So Perl script.pl. What we're going to observe is a similar behavior to the system command. We got the output printed out from our child process, and it's still visible in our terminal. However, we're not seeing anything printed out after we run our exec command. And that is the key difference. When you run exec, it's going to execute a command and quit the script. So all the code you write after that command is simply not going to be taken in account. So nothing is printed to the terminal. So you might be wondering which command you would use when. Again, as always, it depends on scenarios. You might want to list all the files and parse the output from the system command using the backticks to, for example, get all the file names. You might just care about running a system command in background and continuing your execution of the script without caring about the output. Or alternatively, you might want to run some specific output in a use case where you don't want to execute any follow-up code if, for example, some conditional statement was true. It really depends, and it's always up to you which use case you'll find the best fit for the job. So this is it for this video. We looked at 3 ways how we can run system commands using backticks, system keyword, and exec keyword. I hope you found this video useful, and I'll see you at the next one.